Anyway, thanks for coming all. And everyone that has that URL has gotten it, okay? I'm assuming everyone's okay. We can go to the prerequisite knowledge. The things that will make the talk here easier to understand. Basic knowledge about SQL, structured query language in order of importance, structure of SQL, tables, columns, how to create tables, familiar things. Everyone's querying, selecting rows with select, how to modify data with insert, update, delete. We call this DML, data modification language, is a subset of SQL. Joins and grouping, and a little bit transactions, like the idea of a transaction. It starts some kind of work you're going to do. Wow, it's going to be tough with the voice. Do a bunch of things, and then you commit the transaction. And all the things you did in the transaction get persisted to disk or wherever. So, who's used SQLAlchemy before? Familiar with it? Okay. People feel good about it, or beginners about it, or it's not really a question. Who would say they're a novice? Okay, who would say that they've kind of done some SQLAlchemy and have some? All right, good. Your novice is great. Who knows what the difference between the ORM and the core is? Okay, good. Then we'll do that. So anyone that's gone to our website has seen the database toolkit for Python is our tagline. Started out 2005. The end-to-end system for working with Python DB API, which is the Python database API. That's PEP 249, relational databases, and the SQL language. I say SQL. I've kind of decided. We're at 0.97, and I'm working on 1.0, so it'll be called 1.0, which really is just a number after 0.9. It's not going to be. There's no party planned. There's nobody has booked a venue for the big Steve Ballmer. You guys know who Steve Ballmer from Microsoft? He used to come on stage like that. He was great. Great capitalist. The goals of SQLAlchemy are to provide helpers, tools, components to assist and automate development with relational databases at every level. Provide a fully featured facade over the Python DB API. A facade in computer programming is like when you present kind of a simpler way to get at a more annoying set of APIs. Like you've heard of Python requests library. It's kind of a simpler API on top of URL lib and all the junk in Python. That's a facade. Industrial strength, but optional. Object relational mapper. Although I think you should pretty much use the ORM. You should use it. It's optional because ORMs are like controversial, but I think at this point, use it. It's fine. SQLAlchemy wants to act as the foundation for any number of third-party or in-house tools. So if you have your own, you work in a big company, you have a big database application, you might have your own big library of stuff, and then SQLAlchemy is underneath it, giving you all the stuff that you don't have to waste time writing yourself. Philosophies. So we work with a lot of different database adapters. We have MySQL and Postgres and Oracle and SQL Server and Sybase and many, many databases, and they all have different features. SQLAlchemy wants to make it easy to switch between these backends. You can use different backends and do the same things in very much the same way, but we don't want to remove what is special about those databases. So it's kind of a mixed bag. If you write your code with SQLAlchemy, you probably will not be database agnostic automatically. You'll probably have to, simple things will be database agnostic, but if you start using fancy features or even subtle features, you might find that your code will act differently on different databases. So it doesn't really solve the problem of writing database agnostic code magically. It makes it possible to do it, at all. But you still need to be savvy about what the individual databases do differently. So we don't, and as that concept goes, we don't hide the database. We don't hide its concepts. You might call this leaky abstraction. I recently saw a quote by a guy named Gavin King, who is the creator of a program called, a library called Hibernate ORM for Java. You ever heard of Hibernate for Java? And he said that in ORMs, leaky abstraction is a feature, not a bug, which I thought was funny. And I'm like, yeah, Gavin King finally coming onto the scene to say things. So instead of hiding the database, we just provide automation. DRI, don't repeat yourself. Lately, for whatever, I don't know where this analogy, this metaphor comes from in my head, but I've been using the metaphor of the soda bottle factory, which is completely arbitrary. If you have a factory that puts soda in bottles, you ever seen those, those films of all the soda bottles flying and all these crazy tracks and machines? That doesn't mean that you don't know how to actually pour soda into a bottle yourself. You actually know what it's doing. It's just automating the process of putting soda in millions of bottles is much faster than you could do it by hand. Does that metaphor make sense? Because this is the first time I'm trucking it out. It's automation instead of hiding it. So abstraction, in my view, is not that you're going to hide it. Oh, I don't need to know what the data, I don't really care. Just do the work for me. It's not like that. It's going to just automate things that you just like insert into table, insert into table. You don't have to do that. It'll automate that repetitive activity. Which means that you write less code, which means that your code is easier to maintain and change. What does this say? Allow expression of database and SQL using declarative patterns, which is kind of vague, but you'll see. This is the picture that is on the website, although I don't think it is in color. Maybe it's in color. This kind of diagram is called a pancake diagram because they're like these flat things stacked on top of each other, and they kind of show the relationship of different components of a piece of software. So with SQLAlchemy, there's the two parts that we talk about are the core and the ORM. So the core is, but what this means is that the ORM, in order to function, has to use the core. But the core, in order to function, does not need the ORM because it's below the level of the ORM. The core talks to the Python database API, which is not part of SQLAlchemy. It's like the libraries like MySQL Connector Python and CycloPG2 and PyODBC. And then those things talk to the database. So this is kind of where the instructions move. ORM talks to core, core talks to DB API, DB API talks to the database. The ORM never skips through the core. It always goes through the core. So, and then within the core, we have some subsections, and I'll have a little blurb on each one of those. The engine deals with how we talk to the database API, and there's the SQL expression language, and the schema and type system, which talks about how tables and columns are defined in a database. And I think the next slide is going to just say the same thing. Engine, a registry which provides connectivity to a particular database server. Dialect interprets generic SQL and database commands in terms of a specific database API and backend. The connection pool holds on to a collection of database connections for fast reuse in memory. The SQL expression language allows you to write SQL not using strings all the time, but also Python expression objects. And then the schema and type system is kind of at the foundation of the SQL expression language. It uses Python objects to represent tables, columns, and data types and other things as well. So then the ORM, Object Relational Mapper, is a different tool. So you can learn the core first and then learn the ORM later, or vice versa. In this talk, we do the core first. We make our own Python classes that can be mapped to relational database tables. And then the ORM will transparently persist the state of the objects into the database and from the database back into the objects using a pattern called unit of work. We'll see what that is. It provides a query system which loads objects and attributes in terms of your objects, which will make sense later if it doesn't make sense already. It builds on top of the core, as I've said about 5 times already. Presents a slightly more object-centric perspective as opposed to a schema-centric perspective. Meaning the core, you deal a lot with tables and columns and the way your tables are attached to each other. And with the ORM, you deal with your objects. And to a lesser degree, how they move in and out of tables and rows. And then this is a picture that I really should attribute because I stole it from someone else's SQLAlchemy tutorial. And I think I asked him on Twitter if I could use it, and he said okay. But I really have to. I should put his name, if I could remember what his name was. I know how to find him now. You know, internet guy with that picture. Anyway, this is the, and he came up with this idea of how to learn. And the reason I like this because this is how I wrote SQLAlchemy in the first place. I began with just writing the engine and how to connect, and then I dealt with how to define tables and stuff, and then I dealt with how to write SQL expressions. And then after all that kind of work to some degree, then I began figuring out how to do object relational mapping. So you can approach SQLAlchemy. Most people, I think, tend to go to the ORM first because that's what most people use on a day-to-day basis. So you just want to use the ORM and get some immediate gratification and see how it works. And you don't really worry too much about the middle because it's kind of, in some ways, the way it connects and does transactions, kind of who cares. But this talk, being 3 hours long, will start from the inside out. So, and that'll probably, if those of you, it seems like most people have already used SQLAlchemy a little bit, it should probably complement your existing knowledge by going from the inside out to see how we start talking to a database in the first place, so you know what's going on in the center, in the Chewy center of SQLAlchemy. So, and then you see I have for those of you who can see colors, if anyone's colorblind, I apologize. There's a color coding system, the green. So we'll talk about the Python database API at the core. This is a PEP. You know what a Python PEP is? Python Enhancement Proposal. All the Python languages, well, a lot of it, is described in terms of these PEPs that are on the Python website, and 249 is the one that talks about how to connect to databases. This is a de facto system for providing Python database interfaces. There's many of them, and most databases have more than one. MySQL has at least 6 or 7 that we support, so there's probably 3 more I don't even know about. They are all over the place, DB APIs. They have all different, the DB API is not that solid of an API, so they all act differently, they behave differently, they have different quirks and features and extensions. When you work with the DB API, this is not SQLAlchemy, this is what you get before there was SQLAlchemy. This is what the DB API looks like when you program with it. So if you use a DB API called PsychoPG2, that is a really nice DB API for the Postgres database. This is what it looks like. You make a connection. You give it some information that helps it to connect. When you want to work with statements, you have to create a cursor. It's very explicit. The cursor takes a string as well as some parameters. You should always parameterize your queries. After the cursor executes, it now has the state of rows present. You can use the fetch one or fetch many, fetch all to get your rows back. And executing an insert is similar. So basically, every time you want to do a statement, you need to have a cursor lying around, which has its own scope. And then that's within the scope of a connection. And then the connection is always in a transaction. So this is a little bit verbose. It's a little tedious. And you can see if you really had to write a program that has hundreds of different kinds of statements it emits, you might have a lot of this code all over the place. So that would be pretty redundant, be a lot of boilerplate. So we're going to improve upon that in a few slides. Important facts about the Python database API is that it assumes there's a transaction always in progress. With the code we just had, you'll notice that we are committing a transaction, but we never began one. And that's really important, that the DB API does not have a begin method. Some of them do. Some of them have auto commit modes. But the default when you first connect by the spec is that when you connect, you're in a transaction, and you do your stuff, and then you commit. As soon as you commit, that transaction is committed. Now you've begun a new transaction. As soon as you start emitting more statements, it begins again implicitly. And some of you may have heard the phrase explicit is better than implicit. But I think that phrase is overused. I kind of actually like the DB API always beginning a transaction. It's made my life, well, easier and harder at the same time because it confuses people like crazy. So we have that. There's no begin method. There actually is a way to begin, and sometimes we have to do it. But in general, SQLAlchemy does not actually say begin. It just assumes it's a transaction. Oxygen is good for your lungs. DB API encourages bound parameters. When you execute a statement, meaning you write select star from table where column equals, and then you put like a placeholder. It's called a bound parameter. You don't actually put the value in the string. You put this little placeholder, and then you have a second argument to the execute many method that is like a little Python list or a dictionary that has the values. There's many reasons that we do that. Queries are parameterized. A lot of more old school database adapters actually send the parameters separately back to the database backend. The database server actually interprets the parameters. But the main reason most people use them is to prevent what's called a SQL injection attack. Everyone's heard of a SQL injection attack? It just means that you have a website, and the website is like, mywebsite.com, question mark, story equals 5, right? You know where I'm going, right? So the PHP code, because it's always PHP, says, oh, select star from stories where story ID equals 5. And then some, smart ass goes in and says, mywebsite.com question mark, story ID equals, delete star from all my tables. You put some semicolons to kind of make it work, but it happens all the time. SQL injection, you read about these really big high-profile hacks and the Chinese government is hacking. It's so much of the time it's still SQL injection attacks, or even today, just constantly. So the idea of the bound parameter is that you never do that. The bound parameter will just apply the proper escaping to the string. And that's really all it is. It's not that interesting. Python database APIs have inconsistencies regarding pretty much everything: data types, primary key generation, database features, result cursor behavior. They are all over the place. It was really, really hard to write a system that can kind of bring them all to be somewhat similar. The DB API has its own exception hierarchy also, which SQLAlchemy exposes through its own namespace, which is really not as fundamental of a point as the rest of these points, so don't worry. Well, I'll show you later maybe. SQLAlchemy and the database API. The first layer in SQLAlchemy is known as the engine, which is the object that maintains the classical DB API interaction, meaning that slide we had with the PsychoPG2, the engine is designed to kind of provide a new way to work with that pattern. So if anyone actually installed the zip thing, you would do this, and I'm going to do it here. So what that I have here is, this is where, if you were to download the zip file and unzip it, you would see these files, and to install it, you would assuming has everyone heard of virtualenv? Does that sound familiar? People know virtualenv now? I mean, obviously, virtualenv is one of the most critical tools we use in Python, but a lot of times novices don't always know it. Assuming that's installed, well, actually, you don't have to have it installed. If you just type Python install vmpy, that actually builds you a virtual environment. It'll actually use its own virtualenv software installed and give you the whole environment that I have here. If you felt like it, I just put it in the README the other day because we didn't used to have a README. So the README says, if you just run Python install VM, that will install .vm. I'm just going to move forward. I mean, I'm assuming some people are reading that, or do you want to leave it there for a second, or do you want to move? All right, you want to try? Yeah. Usually when we do this at PyCon, people I get a list of people to email ahead of time, and I usually tell them like weeks before the talk. So when we do the PyGothams, usually people don't have the chance to install the software. So don't worry if you're just, I see most people don't have their computers out anyway. So if you just run, technically, if your machine is in decent shape, you should be able to say Python install vmpy just in a directory somewhere, and that should put the whole thing. It should just be like boom, and you don't even need the network for it to work.
And if we already have virtual,
it'll work. It should work. As always, a Windows machine might behave less predictably. It does. This works on Python 2, 3. It's the same thing I've been using for years, and in recent years, no one's had a problem, but there's always someone who's got something installed wrong. And so, you good? It worked? It did a bunch of stuff, and all right, great. What time is it? How was the time? All right, so I think we have a break at 2, so I'm going to go for another hour and 10, right? Okay. All right, so we're all set? You want to make the break later? Is that?
I do because there's a session piloting.
Oh, well, I think our break overlaps with the other break that's already going to happen. Okay. So and so the script is this thing called slide REPL, and you give it a thing, and I'm going to add this flag pres, which makes it clear the screen, and do syntax highlighting. And now we're in this slide system that kind of works as a Python shell. So and then you can see we have one of 13 slides, so you know how long this will take. So this is when you first use SQLAlchemy. And I think probably everyone here who's ever SQLAlchemy at all, this is the first line we have in every tutorial, is you need to make this engine, which is an object that knows how to create database connections. When you do what I have there, nothing has happened at all yet. All it's done is made an object with a string inside of it and some other stuff. But it hasn't, and well, it has imported the SQLite DB API. It's done the import of the module to talk to SQLite, but it hasn't tried to connect yet. It uses a pattern called lazy initialization. And SQLAlchemy is very big on this lazy initialization pattern, which means that you make objects that know how to do something when you needed to do it. So it didn't connect, it didn't do anything yet. But it has established a factory for connections that will talk to a SQLite database in a file called sum.db. The first time you do something, like you can say, hey, let's execute a statement, then it will connect for the first time and then run your statement using a cursor. So here is an example of, now what's happened is when I ran this script, it actually created the database for me really quick. You might have seen it do that ahead of time. So there already is a database with a couple of rows in it that we can play with. So when we run this statement, there's the form of running a statement is typically at this level, a string. Your placeholders are in the string, and then the second argument or arguments are usually named bind parameter names and their values. So this is what it usually looks like at the engine level. It's going to get more fancy than this very soon. The first time SQLAlchemy connects, it typically does some stuff like it wants to talk to the, hey, Mr. Database, what kind of behavior do you have with Unicode and stuff like that. So that's why you see these two things. That's the last time you'll see those things happen. Only the first time it connects, it does a bunch of, like if you connect to MySQL, it'll be like, hey, MySQL, what server version are you? So we can make decisions about what features you have and what features you don't have. This is actually echoing everything that SQLAlchemy is doing. So you can see it happen. So then you see our actual statement, and then it has a little indication of the parameters we sent. And that statement has now invoked, and we have an object called the result with stuff in it, and we can call fetch1 on it and get a row, which looks like a Python tuple. If we repur it like that. It also acts a little bit like a dictionary. It'll have the names of columns in it like a dictionary, so it's not quite a tuple or a dictionary. It's kind of both, because I like to keep people on their toes when I design APIs. And then you can choose to close it if you want to. You usually don't have to close results because they will close themselves automatically when you exhaust them of all their rows. If the result didn't have any rows, like an insert or something, it'll be closed automatically. So close is there. When you say close, that actually means that the cursor that we saw in the PyGotham example is being closed. So it really does correspond to an active result handle depending on the backend you're using. If you're using a backend like Oracle, the cursor is really an active object that's talking to the server. Whereas PyGotham, I think the cursor is kind of like it just pulls the whole thing over and gives you just an object that, hi, Deborah. Deborah comes to all my talks. She's seen this twice a year, actually. Same old talk. Hasn't changed. Same one. Okay, so what do we do now? So you can also iterate result. Let's do it again. Select star from employee. You can, for row and result, print row, and you do that, and that's the data. I'm going to actually have to modify this data because it's not. I actually would like it to be more diverse. I'm totally serious. I've been trying to be less male-centric and stuff. Yeah, this is old stuff. I do try to keep it. Okay, so fetch all is a shortcut to producing a list of all rows. Same thing, you get a list back. And what does this do? So all right, so if you use engine execute with a statement like an insert or an update or delete, it detects that you're using one of those statements and will do auto commit because we haven't told it about a transaction. So when you run that, you see it's emitting this commit, which means that it called connection.commit. So whereas the Python database API does not normally feature auto commit, it's always a transaction, then commit, transaction, then commit. When you use the engine, it'll pull a new connection from the pool, do something, then commit it immediately. So it actually adds auto commit feature on top of the Python database API. So far, so good. since I do this talk the same all the time, and you can watch it online, feel free to completely hijack the talk with any other subject because this material has been done. So you can make new material by asking totally left field, and you had your hand up first.
I don't totally know what auto commit.
Auto commit, yeah. So with the transaction, means that you're working with your database and you say, hey, Mr. Database, start a transaction. Okay, now insert this data. Okay, insert that data. Insert this. Update that. Okay, these are these changes, but they're not actually persisted. If someone else connects to the database from over somewhere else, they will not see those changes. They're not there. I mean, there's some variability to that, but in general, it means they will not see what you've done yet. And you can actually say, you know what, I don't want this stuff. Let's roll it back. It's gone. It's like you never did anything. And if you commit it, instead, it will take all those steps you did and put them in all at once, and they call that an atomic operation. So you have several insert, update, whatever, and then it all packages into this transactional unit that is then sent to the database in one shot, all or nothing. So that's a transaction. So the Python database API always has you doing work within one of these units, and then to end the unit, you say commit. So does that part make sense? Okay. Auto commit means, hey, I'm going to actually jump in there, and each time you do a single statement, I'm going to just commit it anyway. Because at this level, you haven't really told me where you want to start and end your work. So I'm just going to assume that every insert update is just a commit. Because usually when you work with a database, especially like MySQL or Postgres, and you go to the console, they're usually in auto commit mode. So auto commit is kind of what people normally expect. The fact, to be in non-auto commit is usually, we usually associate that with actually typing the word begin. So I always found the Python database API to be a little odd at first, that it does the begin for you without asking you. So when I first wrote this, I flipped it around and made it auto commit by default. And these days I'll say almost never use auto commit, but this is how it'll act at that level. You get it?
What's the colon for?
The colon. So the colon is the format. It's called a bound parameter format, and the Python database API has 6 of these formats. And when we work with the engine at this level, this Python string that we're sending is sent verbatim to the Python database API. So when we work at this level, which we generally won't, you need to know which of these 6 formats is supported by the database that you're using. This is called, I think it's the colon format. I forgot the official name of it. It's colon format. There's also Py format and question mark format, question marks, and there's also numbers. So the SQLite database we're using happens to support this colon format. So we put the colon saying, hey, this is a placeholder that we're going to add over down here as that other variable, bound parameter.
What's the advantage of doing that in that format versus doing the string manipulation in Python? So like, doing a dot format and putting those.
Right. Well, okay. The actual the DB API is doing the bound parameter processing for us. So
Okay.
one of SQLAlchemy's goals is to not reinvent things that are already given to it. And the way bound parameters work is very much dependent on the backend. With the usual Postgres, MySQL, DB APIs, if you look at their source, they are just doing a Py format thing internally. If you work with CX Oracle or PyODBC, they're not. They're actually going to send the parameters separately, and the server actually interprets them. And you have all kinds of, there's actually performance implications. Oracle has a thing called a query, a plan cache, meaning based on the string, it knows the plan, it caches the plan of that query.
Okay.
So if the string changed every time, it couldn't do that. So,
Right, okay.
right. So the bound parameters are actually, at the level we usually use them, it's just a string interpolation, no big deal, but it actually has very slowly bigger implications in a more subtle way.
Sure.
I came from JDBC world, so I just use them, and that's, yeah.
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 So that it's dependent on the database. Does that mean the format and bound parameter changes?
Only, yes, only at this particular API that we're using here. So the engine execute API, which is not really what people normally, the reason it does what you send is because this is the lowest level of SQLAlchemy, where I wanted to make sure that we have a system that you can talk to the Python database API with no, like if there's some weird thing you want to do that SQLAlchemy doesn't expect you to do, this is the level you can do that. Right on I'm not sure it's in this talk, but right on top of this, there's an object called the text object, which means a textual query, and that has a predictable format. So normally, if you wanted to work with strings, in most cases, you would use this construct called a text construct, and you put the string in the text, and that has a much more predictable behavior, and it's more high level. Yes. If you use the text construct, yes. Yeah. There's a little bit of variability as to which, there's different, as you see, as we get to the end, you'll see there's all different ways to execute statements. There's a lot of different places that you might be. Things act differently depending on where you are, but this is the most rudimental. So this is just, it's just a pass-through. But usually you don't really deal with this level. This is just to show, because that's the whole point of the onion, is that like everyone works with the ORM, great, but let's just show what the very core of it looks like first. So that's what that is. Did you have a question?
I was just going to ask, are there facilities for not having this auto commit feature?
Mm-hmm. I think the next slide is going to show you, or next couple of slides. Yeah.
How can I get a list of the different tables in the database?
There is the best way. I will cover this later, but I'll see if I can type it without any typos. Get tables, is that what it is? It's my own API, and I don't know. What is it? Get table names? Like that. So that would be that's the get table names inspection.
And how can I see the fields in each of the tables?
The fields in each table? Okay. All right. We're going to show, you're going to see this in a minute, and there, column names. Get columns. Sorry. Because it's not just the names, it's the whole object about the column. So, yeah. So there's more. There's the other things. There's a feature called reflection I'll show you in a little bit. If I don't. I'm going a little slow today. This is good. Going a little slow. So when we just did this thing with engine execute, we don't know when. I mean, we know when the database when it connected, but if we ran like 3 statements in a row, at that level, we couldn't really predict if those 3 statements would be used on the same database connection or on 2 different connections. So if you want to control the scope of the connection that you're working with, you can do this thing called engine.connect. And then you say engine.connect gives you a SQL connection, which is a little bit like the Python database API connection, but it's much more fancy and high level. So you say engine.connect and you get a connection. Then it works kind of like the engine again. You say connection.execute, select star of employee, you get the result back, and then when you're done with your result, you can close the connection, which actually means that it usually means that the connection will be returned to this connection pool. Although you can configure that so that it actually does close the connection. So here's where we first start seeing a little more of the fact that the engine is using a connection pool, this crazy pooling thing. So this does the same thing. You select star of employee. And then we get to the transaction. So once you have this connection, now you can also, now that we have this scope that will run multiple statements on one connection that we're controlling the scope of, we can say, hey, Mr. Connection, also let's start a transaction. So then we see a more familiar transaction equals connection not begin. We do some things, and then we say trans.commit. This is, I think, did I get this from JDBC? I don't know how I got this. But anyway, this is where SQLAlchemy's auto-commit that it throws on top of the DB API's non-auto-commit becomes non-auto-commit again. So if you run this code, we'll see what you can expect. And then you see there's this begin and a commit. And also SQLAlchemy these days in more modern releases says begin implicit because it didn't actually say begin. The Python database API does the begin for us. We never see it. So at some point, some user on the list was like, hey, SQLAlchemy says it's saying begin, but it's not actually doing anything. And I'm like, okay, well, that's because the DB API has this begin, it does for us. We don't really do it. I'm confused. Okay, we'll put the word implicit to kind of give you a clue that we didn't actually do anything. The DB API, as soon as you begin using it, does a begin implicitly. That was a mouthful, huh? The point is it's a transaction. I think the general idea. Now this gets a little easier syntactically if you just use a Python context manager. I wrote SQLAlchemy against Python 2.3. Context managers wouldn't come out until 2.5. So we were slow to the context manager, the with statement. We were early on. So these days you can say with engine.begin as connection, which is in a transaction, do things, and then at the end it will commit for you without you getting to see it. So this is the preferred way to use a transaction with the engine. If you throw an exception in your block, it will roll back the transaction and then repropagate the exception. Good? All right. Because we're almost through the first quarter of the thing. There's the code. And these are exercises, and we're going to skip them because I'm going too slow. And if you want to do them, you can download the thing and execute an insert statement that will, do Dilbert. Okay, we keep moving on. You want to? All right. All right. That was part 1, which is the short part. Okay, we have 55 minutes left. So far, so good? Questions? Engine facts. Executing via the engine directly, the thing we did in the second slide is called connectionless execution. The engine connects and disconnects for us, behind the scenes, runs the statement, returns the result. Using the connection, when we said connection equals engine.connect, it's called explicit execution. We control the span of the connection in use. The engine usually uses a connection pool, which means that disconnecting, when we said connection.close, it didn't actually disconnect from the server. In this case, it was SQLized as a file, but it didn't actually disconnect from the server. It often means the connection is returned to this connection pool, which just holds connections ready to be used again. And as we also discussed, the SQL we send to engine execute as a string at this level is not modified. Consumed by the database API verbatim, which means that you need to know things about escaping formats and bind parameter formats at that level. It will become consistent at a higher level. Which brings us to section blue, level 2. Table metadata reflection in a DDL. Okay. Greetings. What is metadata? This is a word that I probably knew, but I used it in SQLAlchemy based on this book that I read before I wrote. See, when I wrote SQLAlchemy, I was like, I want to make this thing good, so I'm going to read a book ahead of time. And I bought this book in hardcover because that's computer books usually, the big ones come in hardcover. Martin Fowler's Patterns of Enterprise Architecture. And there actually is a post on my blog where I go through about 20 different patterns in that book, and I show you where in SQLAlchemy I use them. SQLAlchemy was very influenced by this book because I had about 20% of SQLAlchemy in my head, and then when I wrote this book, I had 80% of it in my head. So a lot of what I wrote SQLAlchemy, a lot of it that I wrote, I kind of was stuff I was already using on the job, and a lot of it was stuff that I figured I didn't know how to do, but was in here and I figured out how to do it. So that's how that happened. So metadata, in terms of how Fowler describes it, describes the structure of the database, what we call the physical structure. Is not really physical, but you know what I mean. Tables, columns, oops, that's my microphone. Okay. Tables, columns, constraints, in terms of Python data structures. And it serves as the basis for generating SQL strings as well as for object relational mapping. When you have Python metadata, you can say, hey, metadata, create all to a database. Take all the Python explanations of tables and generate that schema in terms of create table statements. So you can take a blank database, take your Python schema, and then generate. Or if you have a database that you've already gotten from someone, you can do this thing called reflecting, which we did before. You can ask the database, hey, Mr. Database, what are all your tables and what are all the columns and data types and constraints in those tables? And then it will generate a Python metadata structure for you, which you can then object relationally map to if you want to. So you can have a very succinct program that actually will make a full Python API to your database using reflection. And with that, we move to the next slide thing, number 2. All right, so there is some Python SQLAlchemy metadata. So most people here have seen, yeah. What is the software?
Is there something in the zip file?
Yes, there's something in the zip file. So if you open the zip file, if you open the zip file, well, okay, first you'll see this. You'll see those files. Oh, you have a screen over there. Okay. And if you do, in the README, the command that will most likely work for you is just say Python to wherever your interpreter is and say install vm.py. And that will install a whole bunch of stuff, and it won't even use the network. And then when you're there, you can say vm bin slide REPL is the script, and then you give it the name of one of these files like that. Great. And then you can do what I'm doing. Okay. So those of you who have ever typed the command, the create table command at your database, MySQL database, create table test, right? Okay. The SQLAlchemy metadata was intended to kind of look a little bit like that. It's in Python, but it's kind of meant to be structured like it flows similarly. So from SQLAlchemy's namespace of things, we import some names, the metadata object, the table object, the column object, integer type, and the string type. The metadata object doesn't do much. We make one, and it acts as a collection for many tables. So when we are going to make 5 tables, we make one metadata object. And then we declare our 5 tables, and each table, we pass to it this metadata object, and they all become part of that collection. And by doing that, we are able to do things with all the tables at once, like create the whole database at once. We're able to refer to different tables via their string name, like if we want to make constraints between them. So this is this now what we did here. This has nothing to do with talking to a database. This is just a Python object. It's just sitting in memory, and it has some stuff, but we haven't connected to any database, or we haven't done anything with it at all. There's no database in play. This is just a hypothetical table that could exist somewhere, anywhere, many places, no place. Okay. When we have this table, we can say, "Hey, Mr. Table, what's your name? .name. My name is user. Mr. Table, what are your columns? Do you have a column called name? Usertable.c.name is the name of a column called name. Maybe unfortunate choice of naming for the purpose of the slide, but you'll get it. User here, table C keys. My own API again. Here. Here's the full name column. Get it? It's a namespace. You say ID. If you say I'm fake, there's no such column, right? I use the word name a little bit too crazily. So multiple contexts. So yeah, it's a bit like, again, it's a bit like a Python dictionary, but not totally, where you can see my twisted sense of humor of making objects that act like dictionaries, but then will let you down. Actually, that's me. I would have done it differently today, but this was all done in 2005 when I was a Python beginner. Column itself has information about each column. So the column called name is usertable.c.name, and it has a name, which is the word name. So, and then we can say, hey, and this is why they call it metadata. It's very meta. That's a new joke. So this is if they put the video of this online, that will be new material, not in any previous version of this talk that I've done about 8 times now. Usertables.c.nameColumn.type. What's the type of the name column? It's a string. There's other information in the table. You could say, hey, user table, what is your .primary key? Oh, it's this thing called the primary key constraint, which has this ID column inside of it. Great, that's your primary key. Does everyone know what a primary key is? Or have a guess? Who doesn't know what a primary key is and wants to guess? That's too complicated of a question. I'm not a lecturer, so I don't know, like, lecture tricks and how to get the audience all. I'm like an amateur. I'm a total amateur. Great, yeah. I appreciate that. A table object is the core of a SQL expression system. It's a quick preview of that. So right. So if you have a table, you can say things like .select, which will make for you this magical SQL string concept that is actually not. When you say user table.select, it's not actually a string directly. It's user table.select is actually this object called a select object. So S is that thing. If you say print Print S, and then it becomes a string. It's magic. This is a preview of the SQL expression language. So that's how the table is kind of at the core of where we're going to go in the future. So let's take this metadata thing and do something with it. Let's actually generate a schema to a database. Let's make a SQLite database. With SQLite, when we don't give it a name of a file, it does this thing called an in-memory database. SQLite has this fairly unique feature called an in-memory database, meaning it's a database that is only in the memory of the application. It's not on any file or server anywhere. And they're very good for testing things and running little one-offs, and they're also very fast because there's no I/O access involved. So we will make this little in-memory database, and we will say metadata, do a create all for every table and column and thing you have to this target engine. And you will get that. You'll get, again, from before, SQLAlchemy, the first time it connects, always says, hey, Mr. Database, what do you do about Unicode? And, and then it will say, hey, Mr. Database, do you have a table called user? And SQLite says, no, I don't. What do you want to know about this table? And SQLAlchemy says, well, I'm going to create this table for you, user with these columns, and then commit it. And SQLite says, great, thanks for giving me that table. So that's metadata to create a schema. A little quick preview on types. Types get very fancy. So here are some fancier types. You can make decimal numeric types with precision and scale. You can make enumerated types with a specific set of values. You can give lengths to strings and other collations and encodings and all kinds of junk. And SQLAlchemy tries its darndest to get it right. So in the case of enumerated types, SQLite doesn't have an enumerated type. So one of the features that SQLAlchemy has in this enum is that it will create a check constraint. Who's heard of a check constraint? Oh, good. Check constraint, is going to, every time you insert a row into this fancy table, it will look at the type column and do a check that the value you gave it is one of A, B, or C. So that's kind of how an enumerated type can work if your database doesn't actually have a built-in enumerated type. So SQLAlchemy has a lot of type mechanics that theoretically save you a lot of time and trouble. Here's another table that is going to be related to the user table. And in this table, we will, again, say table with a name. You give it the metadata collection as its target. So now our metadata will have two tables in it. By putting two table objects, one with the name user, one with the name address, into the same metadata collection, one of them can refer to the other one by a string name. Say, hey, I'm an address table, and I have this column called user ID, and I would like to have a foreign key to the table that you have known as user and its ID column. Foreign keys? We know what a foreign key is? So a foreign key is what we call a constraint, and you put it on one or more columns in a database table, and the foreign key says this column or columns can only store values that are present in the primary key of another row somewhere, usually in another table, but not necessarily. It means that every value in user ID has to be present in the primary key of the user table. If you try to put a value in user ID that is not already present in the user table, it will throw an error. And that's a constraint. So it constrains you from being able to do something that we don't want to be in our database. We don't want to have any address in our database that does not have a user ID. And that is one of the most fundamental ways in that we enforce data consistency, which is a whole big topic. Makes sense, roughly? So SQLAlchemy is really big on foreign keys, and especially when you use the object relational mapper, you will definitely learn all about foreign keys because they're very important. And SQLAlchemy does not try to hide them ever. It really makes you, it really beats you over the head with foreign keys. If those of you who've used the ORM and relationship, yeah, you know what a foreign key is. Because it's like, you're going to know this. So we could say, hey, Mr. Address Table, why don't you also add yourself to the actual database we have here?
Question on that list. I guess I'm having like meta challenge. So when I print out metadata, I mean, I just typed metadata. It looked a lot like what I was looking
That.
at. It looked like.
You mean that?
That's
Well, it's an object. It has a dictionary stuck on it, I think called tables, and that's where the stuff is. It's really a Python object with a dictionary. That's all the metadata is. It's some other stuff on it too, but. Do you want me to keep going, or? Okay. You can run it all again. You can. That's why I have it down, because the thing is, when I did this talk, we would sometimes, I used to do it with someone else. We would sometimes have a real wide range. So some people were like, I know all this is really boring, and other people were like, he went too fast. So we had this thing where you can take it home and play with it, and you can take it home. All the material is free. Anyway. So what did we just do? We made an address table. So I made this address table, foreign key references. So this is SQLite's foreign key syntax, pretty standard. Create a table address, foreign key to the user. So that's two tables in our metadata with a relationship to a foreign key from one or the other. And this slide is too big for the screen, so let's see what it says. Foreign key is a shortcut for a more long form way to make constraints called foreign key constraint. If you have what's called composite primary keys, a composite primary key is a primary key that comprises more than one column. If your table has a composite primary key, you're going to have composite foreign keys, because a foreign key always refers to the columns of the primary key of another table. You actually can have foreign keys that refer to only a subset of those columns, but that's a more crazy technique. In the normal case, if you want to have a foreign key from this published table to the story table, which has a 3-column primary key, you're going to have a 3-column foreign key. So to join those foreign key things together, you use this other construct called the foreign key constraint, which looks a lot like what the foreign key constraint looks like in DDL. Like this stuff, if this looks funny to you, I think if you just learn DDL, data definition language, which is the create table statement for any database, this would be more familiar, because this really is meant to mimic it. I should have the create for these. Yeah. So if you do a create all for those tables, this is just straight SQLite. So if you know how to do composite primary keys and foreign keys with SQLite, it makes this table called story, composite primary key of story ID and version ID, and then it has a table called published, which has a composite foreign key. So this is just SQL. This is not SQLAlchemy. So if you know SQL, you would know this. And then the idea, because SQLAlchemy was really made for people that already know SQL. So people that are not versed with SQL are going to have a harder time. So it's good to learn as much SQL as possible, because if you know this, the theory was, and I think it's true, that this would kind of make intuitive sense, right? You know what I mean? That this would kind of match, because you have this constraint with the 2 columns, and it kind of looks like, not quite, but it kind of flows similarly. All right, questions? No. Metadata. And exercises are boring, so you can take them home and do it. You make another table called network. Make a create table. When I do the PyCon talk, people paid for the talk, then I make them do the exercise. But you're getting the freebie, so you have to do them at home. So reflection. So now we're back to that topic that came up before, which is reflection. How do I get all the tables in a database? How do I get all the columns in a table? And I showed this API called the inspector interface, which I'm going to show again a little bit. But there's a more old school and probably more widely used API called reflection, which means I can do the same thing I did before. I can say, hey, I want a table. It's called user, but you know what, SQLAlchemy, I don't really want to tell you what the columns are called. I want the database to shove the columns in the object for me. We can do that. We say to the table, we don't give it any columns. We say, hey, table, instead I want you to autoload equals true. And I want you to autoload with this engine. And this came up in Montreal this year. Hey, why do I have to type autoload equals true and autoload with equals engine? Shouldn't one imply the other? So I'm happy to say that in 1.0 that will be the case. So it'll be just autoload with equals engine, and you probably won't have to do autoload equals true anymore. The reason it has autoload equals true is for a long time, people didn't use autoload with. They would have the engine actually stuck on the metadata, and that's called bound metadata. And if you look at many tutorials for SQLAlchemy that are not mine, you'll see metadata.bind equals engine. And I kind of told people to stop doing that a few years ago, and no one's really stopped. But I don't do it. But anyway, autoload with equals engine. For now, autoload equals true. But when you get to SQLAlchemy 1.0, you can just say autoload with equals engine, and that's all you'll need. And when we run this code, you'll see SQLAlchemy will go back to the SQLite database and be like, hey, SQLite, tell me about this table called user. And there's a result you can't see there. Tell me about the foreign keys for user. Tell me about the indexes for user. OK, and it's all there. And now user reflected, the table object that we could have done by hand, now has all the stuff in it. It has the C collection, has the user ID, name, and full name column that we made before. And it has, OK, that was it. It's all there. That's the point of reflection. And then if you want to do the same thing that reflection does, but you don't really want to deal with table objects, you just want to deal with the strings and the names and the stuff, you can use this thing that I showed earlier called inspect. Hey, SQLAlchemy, give me your inspect. OK, inspect this engine. Great. Inspector has names that I don't have to remember this time because they're in my slides. Get table names. Give me the names of all the tables that we've created, right? Give me the columns for the addresses table, and it gives you a little Python dictionary for each thing. OK, and then the foreign keys. I'll tell you about foreign keys, sure. Tell you that the address table has refers to the user table, and here's the columns that refer to, and the constrained columns in the address table. And more extras that you didn't pay for, so forget it.
So
Yeah.
Is there a way to check if like two inspectors are equivalent? So
What would make two inspectors equivalent? That they point to the same database?
So the idea is to have a test in our test suite that builds from Alembic.
Yeah, you want to compare the tables.
Generates, and we want to make sure.
You want to compare the
I
tables.
want to make sure that the developer wrote a migration if they change the model.
So I work for Red Hat now. And at Red Hat, I was hired to work on this thing called OpenStack. Has anyone heard of OpenStack? And they're bananas over this problem. And I'm like, OK, I'm kind of helping. So Alembic, OK, there's this tool called Alembic, which is a migrations tool for SQLAlchemy. And it actually includes schema comparison features. Very incomplete. If you've worked with them, it's hard. It's hard to do.
Yeah.
So Alembic has some features that do this, and in OpenStack they're trying to write test suites that do this, that will run migrations as part of a test and then make sure it did the thing. And it's hard. I'm looking at their code. I'm like, okay, well I'm not there yet. I haven't gotten to their code yet. It's a little crazy. It's just complicated because it's very meta. It's like more meta than I can really, Yeah, look. I can show you an OpenStack where they're doing it.
Okay.
It's a little. I need to get in there and clean it up because it's a little crazy.
Sure.
But yeah, people are they're testing their migrations, which I nuts. I mean, I don't know how I feel about it.
I'm glad to hear that it's a hard problem.
It's hard. You know what though? If I actually spend time on it and I make a nice API that does, then it won't be hard. But I haven't done that yet because I was like, you want to test your mic? Well, that just seems so like. To me, but I will no migrations in general seem crazy to me when I first you want to just write the yourself. So it's that's I'm getting there. So yeah, it can be done. Yeah, I don't they're doing it and it looks really uncomfortable. Is what I would say. But yeah, it might be something that we all have to do. That we don't just write migrations, we have to test our migrations, which doesn't. I can't speak intelligently about it because I can only barely get my head around it. All right, so the way that we do this is that the timing just works out great in this thing these days. This is the epilogue of level 2. Some basic types, just so you can see what we're doing. Integer, string, Unicode, which is like a string, but it's more difficult. Boolean. A lot of databases don't have Boolean, including MySQL, which we tend to use tinyInt, a 1 or a 0. There's a lot of complexity to translating back and forth when you reflect data types. Alembic has a lot of problems with Boolean. A date time type, generate date time, timestamp, other types. When you deal with it at the Python level, it returns Python date time objects. Floats are floating point values like Python F, not decimal types, they're not accurate. And then numeric is precision numerics using Python decimal. Those are some of the types. There's lots of types, and especially if you use the Postgres dialect for SQLAlchemy, there's like 15 more types. that Postgres has that we support directly. It has HStore and JSON and CIDR and Magadir and interval and just on and on and on with the stupid Postgres types I got to support every day. And then MySQL has a lot of variants for types. They don't have so many data types, but they have a lot of flags for their types. Like their string type has got like the national flag and the collation flag and the Unicode flag and all these crazy flags and stuff. So the type API tries to hit as much of this as it can, and people are constantly sending me pull requests for new features with types. It's just it's a never-ending problem. Types, they're tough. Create and drop. I showed you create all. There's also drop all. So you can say metadata create all. You can say table.create. You can say metadata.drop all, drop all the tables. And you can say table.drop. So you've pretty much got, and of course there's a flag called check first, which means, hey, when I drop all these tables, should I check first that they exist, or should I just drop them and throw an error if they don't exist? So, and then with individual table, it reverses the default, because we're always trying to keep you on your toes. All right, so then we're at level 3. So perfect. So then the way it goes is I get through level 3, and then we do the break, and then we do the object relational mapper. And then we get back, we complete the onion. SQL expressions. Anything about metadata, we're good? Okay. SQL expression system builds upon the table metadata we just saw in order to compose SQL statements in Python. So we're going to build Python objects that represent individual strings that we would send to a database. The objects are composed of other objects that each represent some unit of SQL, like a comparison or a select, conjunctions like and or, math operations, functions, all kinds of things. And when we work with these objects in Python, when we send them to the execute system, SQLAlchemy's core will turn them into strings that are tailored for the backend in use, because every database has a different SQL flavor. There's no two different databases have the same exact SQL. They're all quite different. So they will be converted to strings when we execute them, and also if we just send them to the print statement or turn them into a string, they will show us the SQL that they would generate. And with that, we go to the next slide shebang thing. Now, for the SQL, there are two of them. There is SQL Basic and SQL Advanced. I typically do just the SQL Basic. And then when we do the ORM, we do the Basic and Advanced. And the ORM Advanced kind of somewhat overlaps the SQL Advanced. So I generally stick with this and ask as many questions as you can. And if I do it really fast and everyone's like, hey, that's really easy, then we can do the Advanced. But we're going to go till 2 p.m. for that. Right, dashes in there. All right. We begin last week where we made a table object. This is pretty much verbatim what we just had before. Table object, metadata collection, columns, data types, syntax highlighting. We make our SQLite memory database, our throwaway database. We say create all the tables. This is the same as before. The usual waking up, ask for the table, user, nope, make it, there you go, commit, good, great. Then what? So as we saw earlier, the table has a collection of column objects which you can access using the .columnName API. Oh, I think I changed the names here. So it's no longer table.c.name, name. It's username, which is totally arbitrary. Anyway, user table, but it should be easier to understand. User table.c.username is the username column. Great. So what can we do with this column that is interesting?
So that attributes will always want the column name, right?
You mean on the .c collection?
Yeah, so it's like .username lines up with the table name being
The username is the name of the column.
the column name.
Yeah, it's a namespace.
Right.
Yeah. So yeah, SQLAlchemy has a lot of uses for namespaces, meaning an object where names. And we try as much as we can to have those namespaces be separate, because if you say it was user table.username, right, that would be easier, right? But then what if someone had a column called create or something, and then we actually had a command called create, they would conflict.
Right.
So SQLAlchemy always has to deal with this namespaces that we don't want namespaces colliding. So there's the .c. Anyway, yes, the .c is a namespace of the names of all the columns. So username. So now when we take the column, we can do this, if you haven't seen it before, a very unusual thing, which is we're going to compare this object, this Python object, using the Python double equals comparison operator to a string, which is the word ed. Now, normally in Python, when you compare two strings with equals, it'll say true or false. And if you take some totally random object and you compare it to a string, you will get the word false, right? That seems very rational. But SQLAlchemy has played a game with you, and it has overloaded the operator. You've heard of operator overloading? If you took your C++ college, right? Python has that. Has operator overloading. So, and I actually didn't think of this. This operator overloading thing I did when I looked at a library called SQLObject. You heard of SQLObject? So sad. Only one person knows it, and it was when I wrote SQLAlchemy, it was all there was SQLObject. SQLAlchemy came largely from this thing called SQLObject that was written by Ian Bicking. Ian Bicking is the inventor of pip. Heard of pip? It's that guy. Anyway, he's pretty much a JavaScript programmer, I think, at Mozilla now. So when you do this double equals thing, you don't get true or false. You get this object called this wacky binary expression thing. And we have no idea what that is, really, until we start doing things with it, which is if we take that exact same expression and then we say, hey, Python, can we turn this into a string? And it says, sure, and it gives you an actual string that looks like part of SQL. So this is the basic idea of the SQL expression language, is that Python objects that are derived from table metadata, operator overloading to make things more slick looking. It actually is optional, but it makes it more interesting looking. New Python objects that represent compositions, expressions, like an expression tree. If you've ever done compiler design, you work with parse trees. It's kind of like a parse tree. It actually is a parse tree. And stringification that will interpret this parse tree as a SQL string. And the composability means you can take one of these smaller units and then put more of them together. You can make a bigger thing. You can take the two, another equals, and you can put them together with a pipe to do an OR. So you can make a bigger thing. And you can get bigger as big as you want. So you have SQL statements that are that huge, and then you send them to me on a mailing list and tell me why it doesn't work. And I will say PDB. For and or, I tend to not use the pipe symbol. I use these and or functions. So I can say print and say and takes a list of any number of arguments, and it'll separate them all with an and you can take or, put or, A, comma, B. You can put more, comma, C, D. You can say A or B or C or D. So you're building this expression tree, and if you print it, you get SQL. Questions? Yeah.
What kind of recommendations? Do you use the operator overloads or the actual functions?
I use operator overloads for everything except for the and or. Because the reason I don't use operator overloads for the and or is because, can you scroll up? Thank you. The operator precedence is inconvenient of Python. In Python, the pipe takes higher precedence than the equal sign. So you have to put these parentheses, which I find to be less convenient than just typing out the word or. But you can do either. But that's my preference. Yeah, but you start with you could do either way, but I find that usually I first I'll have username equals ed, and then I'm like, oh, I need to do an or here. And I just find that for me, I find it more intuitive to put the or before it and do it like that. You can do either, yeah.
The ampersand, the vertical line works, but do and or keywords work?
No, you can't overload those. Can't overload those. And you know, it's really funny the way Python overloads allows certain things to be overloaded. the things that it doesn't overload, it would be a disaster if it did. So it's kind of funny. Guido's got some kind of smarts in there that he knew what to make overloadable and what not. Yeah, he did the overloading just to the right perfecto, right? Here's some comparisons. You can use greater than, less than. It's just to show us that the idea continues. What is this? Is okay. You can say equals none, and it'll say, oh, that's a none. So we know in SQL you need to do is null. Everyone is really getting into using Flake 8 now, which is great. I am too. So if your Flake guy is giving you a hard time, you can see if I get this right. Yeah. You can say user table C full name. You can say that instead. Because if you use a Flake 8, it'll complain E711. You shouldn't use equals to compare to none. You should be using is, but is cannot be overloaded either, which is good actually, even though it's in here. So if you want to overload your E711, you can use equals null. If you like explicit,
And if you use is there, what happens?
we can't overload is, so it'll actually just say true. It'll say true, yeah. Watch it'll say false. It'll say false, yeah. Can't overload is, which is actually it works out to be good because SQLAlchemy, we need to be able to actually, when you give us all your objects, and they could be anything, we use is to know what that object is without any of your custom crap. So anyway. So the operator logic gets a little fancy. The plus sign can have type-specific behavior. So when you use the plus sign with numbers, you get a plus sign. If you use the plus sign with a string, you get the concatenation operator because it knows that the type is significant for that particular operator. If you, oh no, I want to show you something this didn't show you. Let me just go backwards. 11, G11, go 11. Go 11. I'm just going to do this because I forgot how to do my own slide thing. There's a go command. I can't remember how to do it. Here. SQLAlchemy. Dialects. Import MySQL. And I can say print user table C full name plus. Then I can compile it to the dialect equals MySQL dialect, and will you work? Great. MySQL doesn't have the double pipe concat, so if you happen to tell the thing, hey, we're on MySQL, you'll get MySQL's concat. So that's a quick example of the plus sign can mean many things, depending on context.
Is there a way to know if you're already working in that? Like if your engine is connected to MySQL, that happen automatically?
Yeah, if the metadata of the table were bound to a MySQL engine, then it would do that.
Okay.
Although I don't roll that way too much, but yeah. Anyway, in's a tough one because people often think that when you use a Python database API, you can send like a list to a single parameter, and that the database API will expand it. Most of them don't do that. Usually, you have to write out in, there's 3 parameters here for 3 values. It won't expand them automatically. So SQLAlchemy, when you use the expression language, you can get around the issue of having to use bound parameters. What I forgot to mention explicitly, you might notice that anytime we put a string in this thing, it's not coming out in the statement. It's going somewhere else that we can't see yet. That's one of the things that's nice about the core expression language is that any Python literal you put into it, it automatically shuttles off into being a bound parameter. So you don't have to worry quite as much about making sure you use bound parameters for literals because SQLAlchemy is looking for things that it calls a literal, strings, integers, dates, things that are not clause objects, SQL objects, and it will automatically shuttle them off into a special collection that I'll show you in a minute that makes them into bound parameters. So the core is very good for being good with your SQL injection vulnerabilities. Okay, and that's the next slide. See how I anticipate my own damn slide all the time? The bound placeholders take the place of literal values. So we have this expression, and we say username equals ed, and then ed went away. when we say that, but it's in there. If we were to take that expression object and get the so-called compiled object, which represents a database-specific interpretation of the statement, it will have the parameter list inside of it there. That will be sent off to the database when we invoke the statement. Is that kind of... This means, are you seasick? Bound parameters are extracted when we execute. So we extract it. And you can see when we hit this to SQLite, SQLAlchemy's SQLite dialect defaults to SQLite's question mark parameter format. So suddenly, even though before we were using the colon format, SQLite uses the question mark format with SQLite. By default, you could change it, but it uses the question marks. So you can see the bound parameter formats are now no longer something we have to worry about. They're being handled by SQLAlchemy. We just deal with the string in. The fact that there's a bound placeholder text happens for us. The format of it also happens for us. We don't have to worry about them anymore. But we're still using engine.execute. This is the same engine.execute we did in the beginning, where we had engine.execute a string. If we send a fancy SQLAlchemy core expression, same function, same method call, but it does a lot more work for us behind the scenes. What is this doing? Expressions, yeah, this is dialog. I just showed you this one. Here's the string plus some name. If you do it on Postgres, you'll get the Py format, bound parameter format. If you do it on MySQL, you'll get a different expression. You get concat instead of the pipe symbol. You'll get the param style is different, format style. Exercises, skip those because I am going slow. It's nice. It feels good. Feels good. It's good pace. Insert data using user. All right. So here's the insert. So we have this table, and we can make an insert out of it. So user table.insert. Okay, make me an insert. Insert these values. Username equals Ed. Full name equals Ed Jones. Connect to the engine if we want to, and execute the statement. We get insert into user. Auto commit as before, right? If we say take a similar structure, but we send a list of parameter sets, SQLAlchemy will talk to the Python database API using a API known as execute many, which means that we will send the string to the DB API once and send any number of parameter sets which are invoked more quickly because DB APIs are often written in C and are fast. It might use a prepared statement depending on what we're doing. So this is one statement, two sets of parameters. Another reason we use bound parameters is to send the same parameters, multiple parameter sets with one statement, possibly a prepared statement. The select is how we make actual selects. So this is an example of select. It builds up. Give me a select that will give us the username and full name columns, dot where the username is equal to Ed, and then we send that to the execute, and we iterate through the rows, and we will get the statement, and then we get the row. So this is a way to programmatically construct a select statement. You can select all columns by passing the whole table to select. You can add a where clause, and within the where clause, you can do the conjunctions. You can do or, and, whatever you want that applies to a where. Will go into your where clause. You can say select.where.where.where, and they will, if you do that, they are joined using and. So you get and username and user full name. So far, so good. Exercises. This would be inserted into a user Dilbert and select it. Pretty much a restatement of what we just did. To round out insert select, this is an update. An update looks a lot like, at the Python level, looks a lot like an insert. So it was table.insert.values. It's also table.update.values. We send it a dictionary and a where clause. So that has a set clause in SQL and a where. If you want an update statement that will actually use an expression, like if you want to update a column to the value of some other columns, you can give it expressions with columns in it. So update the full name column to be the username plus the full name, which is a little nonsensical, but you'll get the SQL expression in the set clause. You could do that if you want to do that. And that's a select to see the new data we have, which is usernames and full names are concatenated together. This little tour through core. There's little things you can do. If you go to the tutorial on the site, there's more of this. You can play with it. You can play with this thing. And a delete, which looks kind of like an update, and that has a where, but doesn't have values because the value is going to be deleted. Delete, where something happens. It's kind of the same pattern over and over again. Pretty consistent. And that's the end of those slides. So we have 10 minutes. We can do questions, or we can start doing the advanced SQL, or we could do the break early, or questions?
So if you discourage binding your metadata to the engine, when you're actually compiling your statements, are you just passing around the dialect every time?
Well, these slides I'm doing a lot of stringification to show you what's going on, but usually you're sending things to the engine.
Okay, so then the engine knows how to bind it.
The engine is the bind.
Yeah. Okay.
The engine is the source of the dialect.
Okay.
So yeah, when you're doing stringification, it's a little more annoying, and then you might want to do bound. Yeah.
So for a typical basic class application, will this part of your presentation be something that you see routinely, or is that mostly in your session?
So people are normally using the ORM, which is the next thing that we'll do after the break. The ORM draws very heavily from this core expression stuff. So the expression stuff that you see me doing here with the equal signs and the ands and the ors, you still use that in core. I mean in ORM. You still use that in ORM. So what you don't see as often is the table metadata explicit. It'll be behind your classes. Your class will be mapped to the table. So instead of saying table.c.some column, you'll say my class.some attribute equals 5, which translates to the same thing. So so when you deal with the ORM, you will see core concepts pretty explicitly. You will see metadata concepts that we did a little less. You'll see them too, maybe a little less. And then the engine will be hidden the most because that's kind of behind this facade called the session. So yeah, you really, if you stand on the top of the onion, you'll kind of see the other concepts receding away as you get to the center of the earth. It works so good. Well, Flask, okay, so Flask is a good thing in that it really is kind of like the Django of SQLAlchemy. Like it really brought Python to like a lot of beginners and new people, and that's great.
I hear a big buzz.
Is what?
I hear a big buzz.
Well, everyone's really confused because they've never worked with databases or anything. Like, there's a lot of, and also it has a flat SQLAlchemy is their integration layer, and it's, Armin wrote it a long time ago, and he used older patterns, and it confuses the hell out of everyone. So he's going to update it, and yeah, I mean, SQLAlchemy, I wrote it for myself. There's a integration layer called Flask-SQLAlchemy. It's kind of like it gives you a session that's plugged in, and it's old and silly and does some silly things. So
I think it's accepted a PR on like every year.
yeah,
Just accepted a
yeah, he's grumpy. So yeah, I mean, SQLAlchemy, I wrote it for myself, really. I wrote it like, I'm going to write this awesome database library that I can now be a Python programmer instead of a Perl programmer. And I had been working with databases for 10 years already. So it's like I wrote the perfect library for someone with 10 years of database experience. So a lot of Flask people, it's like they're like my first Python program, and they've never. So if you're learning relational database at the same time, I maybe wouldn't even use SQLAlchemy because it's too much to learn at the same time. If you're learning databases from scratch, SQLAlchemy really, it's kind of like if you know database, it's going to automate your work. If you don't know database, it's going to be hard. If you're working in a soda bottle factory and you don't know how to put soda in a bottle, you might not know what the hell you're looking at. That's the metaphor. 5 minutes more of questions, or do you want me to, yeah?
Question. So in EL, when you're, let's say, creating a num type that is not specific implementation of the database, is there a way to not use two different representations?
Yeah. The type system is really extensible. You can make your own types from scratch. You can take the existing types and subclass them. You can make composed types where you want different Python behavior wrapped around the same database type. Like if you want to have a type that's a varchar, but in Python you want all this fancy stuff to happen with it, you can make a thing called a type decorator that will make all these fancy things happen to a Python type in and out. If you want any num that doesn't do the check constraint or something like that, or
Specifically, one thing about is in Postgres, it has an enum type, but actually it is used.
yeah, so SQLAlchemy's enum will actually use Postgres as enum type by default. If you don't, right? There's so enum has all these. Postgres enum type is a real beast because to get SQLAlchemy to work with it smoothly has been very hard, and there's still a lot of rough edges. When you use the enum type that I showed you, just the way it is, it will, the way it was, create the enum on Postgres. It'll do create type. If you say native enum equals false, it will skip PG. It'll do the check thing on PG. You can say skip the constraint if you don't want the constraint, because I kind of tend to skip. I don't like doing alter on the constraint. I don't really care. You can do that too and have the constraint come in later. You can. It has a lot of flags. PG's create type is really, because you know why it's hard is because it really is this a gigantic change in pattern. Like the type has to be created. Like no other database has that. Only they have that. It's so like reflection gets all messed up and. Migrations are totally, Olympic is having a lot of problems with enums. I don't use PG's enum. I don't see the point. But we're getting, they certainly have created a lot of work for me to get the library to deal with them, and they still are there are a lot of bugs. Yeah, enums.
I'm fairly new to SQL. I'm that class baby you were talking about. So sort of wondering if you could just give some insight on what the value is learning a tool this way. So I know Mongo and I came at it from the the most ORM side of that, and so I now have some data in a database somewhere, but understanding that using SQL is valuable, what are the advantages in learning something like class SQLAlchemy where you really have to have a deep understanding of all this stuff that's happening underneath, if it would be possible to use some sort of ORM thing that didn't require so much knowledge of what's going on.
So the ORM thing, if you Google around for ORMs, and this is always coming up, if you read Reddit programming or if you read Hacker News, and this just happened on Sunday when I was on vacation, another ORMs, blah, 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 you shouldn't use them. And it's just they keep rehashing. And there was an article, a blog post written in maybe 1998 or something, and it was called, very hyperbolically, the Vietnam of computer science. Has anyone heard of the Vietnam of computer science? And it was written by a guy named Ted Neward. And I think he's a well-known guy, and he's some big Java dude. And it was ORMs are like the Vietnam War. They're just a losing battle. He has this enormously long screed of the most endless war metaphor you've ever seen. It was just, I don't know why anyone, it was just this whole ORMs will fail, they'll never work. And I tried to write my own ORM, it didn't work because you have the n+1 problem, you have all these other problems it can't cover. The problem with ORMs, and they'll say this, is that they cannot save you from the fact that relational databases have a lot of quirks and things you have to know about. They can't do the work. It's the soda bottle thing. They can't rescue you from having to know what they're actually doing. And ORMs, and especially back in the 90s and the early 2000s, they were all written you use ORM and now you're done. No more SQL. You just do the ORM and it's all done for you. And you have this whole generation of people that use ORMs without knowing any SQL at all. And then their project fails because you can't work that way. And then they go and they write articles like the Vietnam of Computer Science, or more often today, they Google and they find that article because it's so famous, and they go, oh, there's what I was thinking, and ORM suck because I don't know SQL, and my program doesn't work, and we failed, and it works terribly, and all of our queries are really slow because we don't know what we're doing. So SQLAlchemy's approach was really this philosophy that I haven't seen too much. You see it more now, that, hey, we're not going to hide anything from you. We're going to automate the work. We're going to make the work easier. But if you don't know how SQL works, you're going to do terribly with this thing, because it really makes you write the query. The queries we were just doing just now are, we're making the syntax a little easier, but the physical structure of the query is maintained. There's a select, there's column, there's a where. It's a one-to-one mapping with SQL. And when we use the ORM, you're going to see the same thing. It's still a very one-to-one mapping, and especially we're going to get to this thing called joins. And SQLAlchemy, of most ORMs, does not really try to automate how you join tables together. I mean, it has automation, but it's much more explicit. It makes you have to know about foreign keys and joins, and if you don't know those things, you're not going to be able to use it. So we keep some of the very key relational concepts totally explicit, much to people's chagrin. Like, why do I have to know all this? Why can't I just figure that out for me? They always say, why can I say query from user where user.address.name equals something, and it gets more than one hop. And they want SQLAlchemy to figure out how to join the two tables. They will never do that. Because the join is the core of relational algebra, and we make you do it. And it's more difficult, but by doing that approach, SQLAlchemy has avoided a lot of the problems that Ted Neward's post has outlined. And these ORM posts will either they didn't use SQLAlchemy, or the one that was just up, he actually used SQLAlchemy, he only used the core a little bit. He didn't really use that much, and they reiterate all these ORM problems that, in my mind, have been solved. They haven't been solved like they're gone, but so the general idea is that an ORM can't really work very well if you don't know SQL. The ones that try to hide it totally, you're going to hate. I mean, you'll get something quick and running, but if you try, as soon as you get on the job and you need to do something, you're going to be out. And if you watch the Django ORM, okay, you know it's an ongoing thing because some people love the Django ORM, and because the Django ORM is the classic example of the ORM that thinks that you shouldn't have to worry about SQL at all, and it does all this crazy stuff for you that's out of the box. When I look at it, I'm like, how the hell are they doing that? They're doing this weird thing that you would never want to look at directly. If you look at Django ORM, some people still love it because they're using it exactly the way it was designed. And their use case doesn't go beyond it, or they don't mind not using it when they don't have to. And then a lot of people really hate it. So because they're on a job and they have queries that run terribly and they don't know why, and you can't get into it at all. So the Django ORM has gone very far with what I feel is the wrong approach, but they've taken it very far and they've been quite successful with it. But you know, if you any shop that is like a hardcore SQL shop is not using the Django ORM. You just can't. If you work in like finance and you're doing OLTP or whatever, Django ORM is not going to do it. You need explicit stuff. That's just a philosophy. So it's a philosophical question. There's not a simple answer, as evidenced by my 10-minute answer.
That helps. I do actually have experience with Django ORM and it not fitting use case and like manually writing.
Yeah, right. So that's when Ted Neward wrote the Vietnam, he meant that. Now, but he was meant back when they were like these big clunky Java things that were way worse. They had XML files, and that's what we didn't have this declarative stuff, because they didn't. Java now does use inspection of code to determine mappings, which is they do that in Hibernate now. But in the 90s, the only way you could describe anything was through XML, and we had to walk 16 miles to school every day. Okay, break time. All right. Object relational mapping. All right, what do we got? So, what do we know? What do we mean by that? The process of associating object-oriented classes with database tables. When we do this, we have a bunch of classes that refer to tables. We call this our domain model. You write like a banking app, your account table and your customer table, the objects that refer to those tables is called your domain model. And here we have kind of a little diagram of what the most absolute minimal thing an ORM has to do is to persist and load one of our domain model's objects into a row of a table. And this is, if you don't do this, you don't have an ORM. If you do this, then you have the most rudimental ORM possible. And then most, well, no, not this slide, the next slide. Some ORMs can also persist your domain object into, they can load objects from arbitrary rows. In databases, a table has a lot of rows, but then if you select from some tables, the select statement has its own rows that are derived from those two tables. And if you join, you have a join, the way relational algebra works is that rows can be derived from other sets of rows, and then you can get rows from that. Any kind of row you have anywhere, an ORM could theoretically turn those rows into the state of a domain object, which is a more flexible idea. Most ORMs can represent what's called compositions. This is really where they become useful. In domain object land, we have collections of objects that are associated with a parent. So here we have parent with a one-to-many of child objects, and they each have an implicit many-to-one association with their parent. In a relational database, that's represented by what I mentioned very early, which is the foreign key. Table 1 and Table 2, if there's a foreign key that refers rows in Table 2 to require that they refer to a row in Table 1, you can relate that in domain object land to one-to-many and many-to-one relationships. So this is really pretty much every ORM does this. They have an object with a collection of sub-objects, or they have an object with a many-to-one to some other object, and that's always represented by the foreign keys. So in this case, Table 2 has a foreign key refers to a primary key in Table 1. You have the one row in Table 1 with your parent, and then it has two rows that refer. Now, when I first wrote SQLAlchemy, just getting this in my head, the backwards, it just took me like years of writing the code with one-to-many, many-to-one to have this kind of thing kind of somewhat automatic in my head, and it just foreign keys, it's just kind of a mind flip. And if you're starting out with SQL, it just takes a lot of practice to just get the many-to-one, one-to-many thing to make sense on a regular basis. What else does an ORM do? They may or may not provide a means of querying a database in terms of the domain model structure. You'll see what that means in a minute. Some can represent class inheritance hierarchies, like if you have, if you go to some very classical example of class inheritance, you have the vehicle class, and then you have the car subclass, and the train's another kind of vehicle. You might have a table called vehicle, and you might have a table called car, which has a foreign key to vehicle. Maybe you want to represent those two tables as inheritance rather than a relationship. Some of them can do that. Some, this is a little more miscellaneous, can handle sharding of data. So if you want to have all of your user accounts in one database, and you want to have all of your email addresses or other data about them in some other database, that's called sharding. You might have some data here and some data there. You could be doing horizontal sharding, where you have billions of users, and all the users that are A through F are in one database, and G through M are in another database. You probably wouldn't use that scheme, but that would be sharding horizontally. Provide patterns for concurrency, like you have your application does things in a transaction. What if two different threads or processes try to do the same thing at the same time? If they both try to impact the same row, and one transaction changes the row first and the other transaction tries to make a change to that row, but it has the stale data, maybe there's some patterns you can use to raise an exception if you want, if that's an important thing to catch for. Patterns for data validation and coercion, if you have your domain model and the data that goes into the database has got to be a certain format, or dates have to be in certain ranges, or things have to match up in certain ways, certain constraints need to be met before the data goes in the database. You can have various events that fire off before the ORM persists the data, things like that. So a lot of handy things. Flavors of ORM. Two general styles you'll hear about is active record and data mapper. I tend to think of active record as meaning that when you make an object in your domain model, that object is kind of its own little silo of database access. So you make your user object, and this is how Django ORM is. You say, Django ORM, give me a user record.save. It'll say insert into database user. And then you say user, change your full name to something else. You say user record.save. It'll be like update date user, set full name equals the new name, where ID equals the ID. The point is the save method is on the domain object, and it kind of does its own thing as far as connecting to the database, talking to it, and coming back with a result. And then you might have a query on user, like user class, give me a query, give me all the user's name, ed, things like that. Data mapper, in my interpretation, is not that different, but it kind of says that there's this other object, which we call a session, that is kind of like the scope of work that you're doing. And the session represents kind of the place that you get data from. It's the database connection, but it's a lot more than that. It's a place that you can pull objects from and put them back in. And so the the object we deal with does not have quite as much awareness of how it's persisted. You send it to this session, and it goes to some database somewhere. So it's a little more broken up. Yeah.
Doesn't the active record flavor typically have that same thing going on in the background anyway?
It does, but the point is, when you as the programmer don't make it explicit, so the active record system has to decide when those points begin and end. And I did a talk 2 years ago that gets into a lot of the gotchas that happen when, basically when you use the Django RM. So, no, sorry, I'm on camera. No, no, it's not like it's terrible. It's just a different pattern, and it can lead to various issues that aren't terrible issues. But if you use the data mapper, it's just upfront a little more clear as to the objects don't handle their own persistence. They don't know where they're persisted to. You can kind of persist to here or there, and it's not their choice. And more importantly, the scope of persistence is defined so that when you do data mapper, you can use this unit of work pattern, which means that the unit of work can decide when to push changes. It's not like save, insert, insert. It's kind of like more of a deferred pattern where the system can make more intelligent decisions about how to do things. And it's subtle. I did a talk a couple of years ago at PyCon that kind of gets into here's how it's subtle, but here's how that pattern can help you. And people that use the unit of work pattern, like the pattern a lot. It works out really well. It's a little subtle to explain, but we'll get to it. Flavors of ORM. All right, so different configurational patterns. I used to kind of think active record meant this. It meant that you define your classes and your tables all at the same time. And now that SQLAlchemy offers the same way of mapping things, I don't say that anymore. But maybe active record is kind of this too, that you make your class and you make your table definition all in one big blob. This is how everyone does it. Now, it's not as pure. You might want to say that I'm going to make my business objects, and I want them to have nothing to do with the database. I want to have like table metadata all somewhere else, and my data objects have nothing to do with these database tables. They're totally separate. The reason that is not totally pragmatic is the fact that the columns in the database table are pretty much going to be attributes on your class. If you use Java Hibernate and you have a class that you're going to persist and you have your Hibernate XML file, every column in the table is going to have a get user, set username, you're going to have getters and setters anyway. So even Hibernate has a system like this with Java annotations where, look, there's no point in making the columns over in this XML file and the class over here and pretending that they're totally separate, because the point of an ORM, one of the things an ORM does is it instruments your class and changes the behavior of your class such that it's going to persist. Things that are the state of your object is going to be determined by the database. So it's kind of impossible for the behavior of your object to not be impacted by its persistence mechanism. And Ted Neward would be like, ORMs. But anyway, so this is actually SQLAlchemy code, and this is pretty much what it usually looks like. Now, originally, when I was like data mapper all the way, we're going to keep it totally separate. We're not going to make any of those mistakes, so we're going to avoid all of Ted Neward's criticisms, is to use like pure data mapper, which is like you actually have the user, which knows about, it has a name and a username. That's all it really knows. And then totally somewhere else, it's mapped magically to this table object, which also has this primary key ID. And you don't see the ID up in there because user doesn't care about its persistence. It's totally, I have no idea how I'm persisted. This mapper thing elsewhere does it. So this is how SQLAlchemy, up through version 0.4, this is the only option you really had. There was a product called Elixir that kind of tried to do Ruby on Rails style config. SQLAlchemy had some extensions. We've moved away from this. When SQLAlchemy 5 came out, I got a job. I actually got my first job that was a Python job, where I was actually going to be writing Python code for money. Until then, everything I did was either Perl or Java. And so this is going to be the first time I was actually going to use SQLAlchemy on a job. And I just looked at Elixir, and I looked at this, and I'm like, there's no way, none of this can work. So I wrote this thing called declarative, which kind of basically, was this, yeah. I basically wrote this as declarative. And because when I was presented with my own API, I was like, oh, I'm not going to make all the tables over here and make all the mappings over this. It's going to drive me nuts. I need to have it all in once. So, practicality beats purity. So the SQLAlchemy ORM is essentially a data mapper style ORM in that we try to keep the domain objects kind of separate from how they're persisted, although not 100%. Modern versions use the declarative configuration. The domain and schema separate configuration model is still present. You can certainly use it. The mapper is there. It actually happens. It's just not what we usually see explicitly. The ORM builds upon the core. And a lot of the core expression stuff that we looked at still happen in the ORM pretty much the same way that we did. And in contrast to SQL expression, which presents a schema-centric view, we kind of deal with more of a domain model-centric view of data. We don't really see the tables too much, but typically the tables are kind of mapped to our classes, so we kind of deal with relational concepts, but more in terms of our domain model. Key ORM patterns that we use in SQLAlchemy, the unit of work. Objects are maintained by a system that tracks changes over the course of a transaction. It periodically flushes these changes in a typically transparent, or if you want, semi-transparent manner. The identity map goes hand in hand with the unit of work pattern. When you pull up an object of a certain primary key, and if you pull it up again later within the same session, you'll get the same object, meaning that objects are keyed to their database identity within the scope of the session. It's a mouthful. You'll see it in practice in a little bit. Lazy loading, which is a great pattern, and this is why you cannot integrate SQLAlchemy style ORMs with Twisted or any kind of explicit async programming. And if you ever see me writing about Twisted or Node.js or Tulip, I'll be like, hate, because ORMs do not work with async code. They will work with implicit async code like eventlet or gevent, but they will never work with Twisted directly. I mean, you can use SQLAlchemy with Twisted for sure, but you can't have the whole Node.js async callback thing with ORMs because lazy loading is the antithesis of that. Because when you work with Twisted or Node or any of those explicit async approaches, the entire point of them is that anytime the system is to make an I/O call, you are not allowed to just let it make the I call. You have to get this thing called a deferred back from it or some equivalent yield or something that says, it's I/O. Everyone panic. I/O is going to happen. We have to totally turn our code inside out. And this is not a well-reasoned rant. But it means that you can't implicitly make I/O and just keep going along your merry way. If you do any kind of input I/O with a database, it's like a big deal, and the entire structure of your code is impacted by that.
How do I disable lazy loading?
You don't have to use lazy loading. First, if you don't use relationship, you probably won't see it. I mean,
But if I do want a relationship, I'll explicitly join it.
you can. All right, you can. Yeah, you can. So eager loading will do it. You can have all your relations eager load, but however, you wouldn't. Eager loading doesn't always work out the way you want it to. You can have a relationship do a no load and then populate it later if you want. It's not easy. It's not convenient, but there's ways to do that, and the API could be. You might have to. Yeah, I mean, we could do that. Maybe with an event or something. It might need some tinkering, but it's doable.
Yeah.
If you really want, I mean, no one's really come to me and asked for that. People have kind of said, but no one seems to be really motivated to come to me. But yeah, we could make a loading strategy that throws an exception. Sure, we could do that. It's not, yeah, you can do it. I mean, yeah, to get it to be really the way you want might be more involved. But yeah. That would be good if we could figure out how it's really going to work in practice. If you want to use it with Twisted, we really would. This is the thing. What are the patterns that you really want to have in Twisted? There's a lot of problems with async in that if we really, first of all, the DB APIs are usually not async. PsychoPG2 is the only one that's purely async, that has a real async API, and it really would blow the engine to smithereens. The whole engine design would be really so many callbacks. That would add so much overhead.
I'm not so concerned with performing async I/O.
Yeah.
Just not having these big queries.
You don't like the implicit? Right. Yeah. There's ways to. Yeah, there's a no load, but yeah, if you want it to blow up, there's ways to do that. There's several different approaches. Eager loading, multiple tables are queried at once, and if we get all the way to the end, even though I'm going kind of slow, we'll get until 4 p.m. Okay. I have some examples of that coming later. Method chaining, you've already seen some of this. Queries are composed of a string of method calls. So when you say, select dot where this dot order by that. And you see you keep saying dot this dot that, and you keep getting this object back that you can keep calling. That pattern is called method chaining. A lot of SQLAlchemy's docs call it generative, and I don't know why I called it that, but it's really method chaining. But if you see the word generative, it means method chaining. And then we go to the ORM walkthrough. All right, so we finally begin with a little bit of a different thing. No more of that create engines. Well, we'll have create engine, but no more metadata. The metadata is there, but instead we have from SQLAlchemy import declarative base. The declarative base is a special kind of container. It's a base class for classes that will be mapped. It's part of the so-called declarative system in SQLAlchemy. As I mentioned before, you don't actually need to use declarative, but most people do. It's definitely the easiest way to go. When you make a class that is a subclass of a declarative base, it's using Python metaclasses to register the fact that you made a mapped class of a certain name. It is also running a lot of stuff to figure out that it should create a table object that is actually there behind the scenes based on the table name you give it and the columns. The reapr method we have there is just so when I run this code you can see the object more clearly. So this is what a basic mapping. So it looks kind of like the table metadata, but not exactly. It's a little bit different. It's a little more slick. The columns don't have string names inside of them. They can if you want, but there's a convenience feature which is such that you can use class attribute syntax, and the name that's on the left side as the attribute name for the user class will be stuck into the column as its name attribute later on. So the declarative mapping is kind of like some convenience system so that you can create a table object behind the scenes and also map a class at the same time. So when we did that thing we just did, the meta class ran and created a table object for us. So you can see user double under table. You can see the table object that looks like the one we created up in the previous tutorials. And it also has this magical object called a mapper, which we don't have to deal with too much explicitly, but that's going to be mediating how the user class is related to the table that it maps to. So when we have our class, we can make a new user object. Just a regular old Python construction with keyword arguments. The keyword arguments are kind of implicitly set up for us in the constructor by declarative. The names that we can use match the names of the attributes that we've mapped to columns. We can make our own constructor if we want to do other things. When we make this object, it has this implicitly none ID field, which is because our table has a primary key called ID. If the table had a primary key of some other name, then it would be another name. But because we gave it a surrogate integer primary key of ID, there's an attribute called ID there. If we hit it, we do not get an attribute error. We get none. Python SQL always got some behavior that says, well, it's going to be null for starts, and when we insert it, we might get a value for it. So when we made the declarative base, it has a collection. It has the metadata thing that we had from the core chapter is actually there. It made it for us. We refer to it pretty much just this one time, if and when we want to do the create all. So this is again the create all that we did in the core section. We're going to create the tables. There's a table, same old thing that we've seen before. So far so good. Any questions? Yeah.
Did you generate hate from the community for like the magic that goes on behind like creating the mappers relationships automatically after you declare your classes?
Is the question like can you generate that?
No, I mean I know how it works. It took me a while to wrap my head around it the first time I read about it, but it was like did that confuse a lot of people when you first created that?
You mean the declarative or the fact that it adds?
The declarative method, yeah.
I don't think it confused people too much. What declarative does that's confusing is that it replaces the attributes that you put there because declarative SQLAlchemy wasn't written with declarative from the start. So when you say class user and you say name equals a column, there's a column object there. But once it maps it, it takes the column away and puts a different attribute there, and that's confusing. And amazingly, people don't hit that too often. If I had designed, have you ever heard of the Storm ORM? Isn't it great? No, there's an ORM called Storm that was written by Canonical a while ago, and they have a more simple design, which is you make the class, there's an attribute, and it's the actual attribute that stays there. It's the persisted. It's more simplistic, but SQLAlchemy has like table metadata and then mapped attributes, and everything's different. So the fact that declarative was bolted on later makes it a little more weird, but people have not been confused by it. There's a feature called mix-ins with declarative that does confuse people because it is confusing. It's very useful, but it's hard. It's harder. It's not hard, but it's more easily confusing. So now we're going to start talking. So as far as the ORM, what we've done so far, we've kind of done the setting up of table metadata that we did in core. We haven't talked to it. Well, we made the tables, but we haven't done much else with the database yet. When we want to put rows in the database and load things from the database with the ORM, we use this object called the session. So we have done the create. We've done the create engine that we did before. We take that engine and we don't really work with it at all anymore. We're going to just send it off to this session. The session is going to be the object that we really go back and forth to the database when we use the ORM. If you're not using the ORM, you probably don't need a session. The session is an ORM-specific object. So we say to the session, hey session, make a new one and bind me to this engine. Now, in keeping with the original lazy initialization patterns, nothing has happened here. This is just a session in an engine. No database connection is implicit in this operation. Nothing has started. No transaction has begun. Nothing has happened at all. But as we begin to use the session, it will then say, hey, engine, give me a connection. And hey, engine, start a transaction for me. And hey, let's start getting to work. And now we're going to start doing things. That all happens for us as soon as we begin to use the session for things that require database access, which does not include this operation. In this operation, we have this user object, and we have a session object. We're going to say, hey, let's put the user object into the session where it will become what we call a pending object. Nothing has happened. There's still no database connection yet. We still haven't inserted any rows. The session, when it decides that it's time to persist, to flush its changes, will convert that operation into an insert statement. And in fact, it will do that at a few different times, but one time that it does it is when we're about to query. It seems a little weird at first, but this is actually how a lot of ORMs do it. This is how Hibernate does it. This is how Storm does it. We're going to say, hey, session, we want to query for this table. And the session's like, OK, well, let me flush out my pending changes first to the database before I do the select statement. So it's going to do a flush. So you'll see, and this is what confuses people sometimes, the fact that when auto flush is turned on, which is also an optional feature, although people like it, I like it a lot, doing a select statement means that you might have an insert statement preceding your select. So you might have a lot of insert statements. If you have a lot of objects and changes that are pending, and you are using auto flush, which if you don't like it, you can turn it off. It will flush a lot of stuff before you select your rows. SQLAlchemy did not have auto flush until version 5, version 0.5, because I thought it was a little crazy. But eventually, after, again, it's another one of those seems terrible in theory, but it's great in practice kind of things. Like, it's really surprising that doing a select would implicitly mean that things are inserted first. Auto flush is pretty much, you should use it. The fact that the session is in a pending and uncommitted transaction is one of the big reasons that auto flush is feasible. If flush meant that that insert was persisted to disk, it would be pretty annoying to actually persist changes to disk every time you make a select. But it's not. It's all a transaction. It's all fluffy stuff that could be gone if you roll the transaction back. So that's kind of how it works by default. It's very configurable if you don't like it to do that. Yep. Yeah, and I would not use, if you're using auto commit and you're not beginning a transaction, I would not use auto flush. Because you don't want to auto flush and persist things. I don't use auto commit with a session. If I'm using auto commit, it's only so that because the integration layer I have is going to emit the begin explicitly. Meaning if auto commit is on, I don't use the session until I begin a transaction anyway. So meaning I don't use the session outside of a transaction. And if I wrote SQLAlchemy today, that would be how it works, period. There would not be an auto commit, but legacy. Because I didn't know back then. I only knew about half of what I was doing. Once we've inserted that row, SQLite, along with a lot of other databases, has what we call an auto increment behavior, which means that typically a surrogate integer primary key just by itself will be able to generate new values for itself. Postgres has a column type called serial, which creates a sequence that does this. MySQL has an auto increment feature that we probably all use. SQLite has auto increment. And this was a big challenge of SQLAlchemy to figure out how to get these stupid primary keys back after you insert the row. And it's a real big deal. It really affects a lot of things to get that number back. But we need that number because the ed user is now going to be in this thing called the identity map, which means that when we talk to ed user again, it's always going to be from this mapping that knows that the row in the user table with the primary key of 1 is always that same object within the scope of this particular session. So if some other part of our code also refers to that same row, we're going to get the exact same object back so that all the things we do are on the same Python instance. Because right here, up here, okay, so I said I assigned this query to give us the first row in the table to a variable called rUser, but then the variable that we persisted was this other object called edUser. So there's these two Python variables. One of them was an object we constructed. The other one was an object that the ORM gave us back from a select statement. The identity map says that they are the same object because they're the same database identity. And that's what the identity map means. And that's really, it's a pattern that it's kind of hard to stress how incredibly handy that is and how many problems that solves. Like it solves so many problems. The identity map is just this really crucial ORM feature. Yeah, this is why I love that the Python is operator cannot be overloaded. It means they're the same in-memory thing, period. There's no shenanigans possible. In Python, the is operator means only one thing, and it can never be changed. Session has some other APIs if you want to add a bunch of objects at once. We have three more rows that are now pending. And we can make a change to our existing class. These are all pending things in the unit of work in the session. We can look, before we flush these changes, we can say, hey, session, show me the objects that are quote unquote dirty, meaning they have some kind of change that hasn't been persisted to the database yet. That includes the set of the user ed, where we changed the username to Ed Jones, a full name. We have the new collection, which is objects that we call pending. They have not been inserted yet. These are rows that are not present in the transaction yet. They're just in Python. The session is going to flush them. It's going to insert them when we do a flush. So the session.new and the session.dirty collections are ways that we can kind of get a view into what the session will do when it does flush. Sure. When you do a commit of the transaction, this is actually going to commit our transaction. That's the other event that also implies flush, right? Because you have to auto flush whatever changes are left before you commit the transaction. So when you commit, it'll do the flush, and it'll do everything that we just did. It'll make our change to the user table, and it'll insert the other three rows, and then commit. So that is kind of one run-through of a session. Now this is also default stuff that you can change. When the commit is done, by default, SQLAlchemy expires all the data that we know about. So this edUser object has a Python, it has state, it has ID, it has .name, .fullname. The session is going to erase them. It's going to remove whatever we had there. And this is another place where lazy loading that you probably want to get rid of happens. But this is how intrinsic lazy loading is to ORMs, is that the transaction is over. If you know about transactions and how database isolation works, if you had a very highly isolated transaction like serializable isolation, this would be the point at which other transactions can be going in there and changing all the data behind our backs. Like in theory, in a totally pure world, when we're in a transaction, everything that we do cannot be affected by the, if you're in serializable isolation, everything we do can't really be affected by the outside because we have a lock on the table, or we have the multi-version, the version of data that will be persisted, and if it can't be persisted, it'll throw an error. This is kind of a subject a little beyond the scope of the talk here, which is why I'm glossing over it so terribly. But the point is, the session has this default decision that it's the end of a transaction at which we should decide that the next go around we should go back and refetch everything. If you don't want to do that, you can turn it off, and I usually often do turn it off depending on how I'm doing things. But the default decision, and you might want to have it forget about data even sooner if you want to, if you're in the middle of a transaction, you want to be able to see other transactions in progress if you have a lower level of isolation. Anyway, the point is that user is empty, and the next time we hit .fullName, it's going to actually run a select to refresh the contents of the object. In practice, a lot of times, if you're writing a web application, you're done. Once you've done the commit, you're done with the objects anyway, and you throw the whole thing away anyway. So often this doesn't really matter. If you have an app that needs to read the data after the commit, but you don't really care that some other transaction might go in there and change it again, you can turn auto expire on commit off. That's all there. It's not that big a deal. But when I have people that really are doing like some kind of long-running transaction, they do this, then they commit, then they keep it running, they keep going. They'll come to me like, I have stale data. When is the data going to be reset? And when I added this expire on commit, all those people stopped complaining. So it's a decision that you might not always want, but it does work in the default case fairly well. And then to the expire on commit kind of is related to the expire on rollback behavior. We might make some changes that we are going to roll back. So we'll make a change to the add user name. We'll make another user that we don't want. We'll add that. Because remember, after every commit, we're implicitly in a new transaction again. We'll do a query for that stuff, and it'll do the implicit flush. It'll update the user table. It'll insert the new row. We select the data. We get it back, but we're in a transaction that's not committed yet. We then say rollback those changes. That actually will roll back the transaction. The data is gone. It also, again, expires all the data in our session, and also the objects that were added are pushed out again. And we'll see that state is back to where we want. We look at adduser.name. It's been expired. So we hit it. Let's select it back again from our now rolled back transaction. We get the new transaction, get the old row, going too fast, get the old row back, get the old name back. And the user that we didn't want to add because we rolled it back is also out of the session. Now, all the talking I'm doing is really complicated, but what I did up there should look kind of like what you expect, right? That I did some changes, and then I had a rollback, and then it was gone, right? But what's actually behind the scenes is a little more Byzantine. Any questions on that? That's the general idea of a rollback. It's a little. That was not in SQLAlchemy version 1. That was another version 5 thing. Version 5 was when I really was like, oh, that's how that should work. This was not how it used to work. I had no clue how to do this for the first 4 versions. And because the transaction was rolled back, we do the same select, and those rows are gone. So the fake user row is gone, and it's back to how it was because the transaction was rolled back as well. Okay. Exercises. Blah. Any questions so far? Okay. So here's the whirlwind tour through querying. Same as the thing with the equal sign overloaded, the table equals, you see the same thing happening. So instead of usertable.c.name, now it's user.name. The .name attribute on our user class is kind of like a column. It's actually not a column object. It's a different object, but it acts like a column object. It does the same thing. It makes a SQL query. The query object works similarly to the select object that we saw in core, although, it has a little bit of a different starting API, and it is based off of the session instead of a standalone select. So when we're using the ORM, the session object is really providing the context for what connection we're going to talk to, what transaction we're inside of. It kind of provides this kind of nest, like a nest for all of the stuff we do is in terms of the specific session. So the language is a little bit different. It's a filter instead of where, order by. Same idea though, and you say query.all is one way to make it invoke and do a select and give you back the rows, which are also not those little tuple rows. Now it's like a list of objects. So it's a little more heavyweight. It's actually the whole object in a list. Instead of having to say fetch one, fetch all, it's a plain Python list with an object in it. You can query for individual columns rather than entities, and you will get back kind of a named tuple. So this is kind of like when you did core select, although it's a little more high level. A query like this in the ORM also does a lot less work in Python than the query for the user object as a whole, because when we load user objects, we have to do all the identity map stuff, like all the rows that come in. Do we already have this row? Is it in the identity map? Do we pull it from the identity map? Do we populate it or not? When you query for individual columns, all that work is skipped, so it is faster. If you want to just get some data back quick from the session, this kind of gets into the fact that Python is kind of a slow language interpreted. To do complicated things can be expensive from a function call perspective, and if you have an app doing a lot of queries, you probably want to be aware of how to do this to save time if you don't really need the whole object back. Uses less memory too. You can mix entities and columns together. You can say, give me the user and the username. You can get that. This leads into one of my favorite tricks that I do all the time, which is the dict constructor. It's Python dictionary. Session query user name user. This is slick. This is the Python dictionary, and you hit the session query with username and user, and that's it. And you get this, and then you get the dictionary keyed by name. Isn't that cool? That's because the query will iterate. It's an iterable, so if you iterate it, it'll go and iterate stuff. And the Python dictionary constructor works like this. If you say dict, you could say key value key to. I'll get it. I see it. I'll get it. I probably do this too because I bet it's not going to work if I don't do that. Woohoo! So it's basically the same as doing that kind of operation. So you get this. So if you want to get a dictionary of users keyed by name, you can just throw the query in there. I do this a lot. What do you mean for the key? You mean? There is a way, but I'm not going to get there's a thing called a bundle that can. Yeah, there's a way that you can. It's not going to work right now, but there's a way you can make it do this. That can be done. That's not the syntax, but there's another object I added in 09 that can make subgroupings of columns like that. It's not that easy though. But you can get the basic idea can be done. Not as nicely as that though. That would be nice if that could work, but that's not maybe. Yeah, it might be a good idea actually. That actually could work because it's a tuple. This is the thing is every time I do these, I do get new ideas. Yeah, that's possible, but not as nicely. But maybe it could figure that out. I'm not sure. That would be pretty cool. Version 1 maybe. You can do array indexes. This is a trick that all the ORMs do. I almost don't even use it. If you treat the query object as an array, you can use array slices and indexes, and it'll do the limit offset to control which rows you get. And if you do a slice, within reason, it'll do the slice stuff for you. It's like a syntactic sugar thing. The where clause is either via the filter by, which is convenient. Filter by is a quickie filter which just takes keywords. The keywords basically match the names of attributes on your map class. So full name equals Jones, and you can say filter by, full name equals Jones, comma, ID equals 12, and it'll give you that. It's a very quick way to just do equality. And then if you need to do filtering that's more, specific, different operators other than equals or not equals or and or, use filter. So they're kind of the same thing, but filter by is a little more high level, a little more quick and dirty, and filter is more of the full blown slightly more verbose system. I use both. You can pass conjunctions just like in the where clause from our core select. You can say or, do that kind of thing, less than sign, whatever you want. Just like with the select, if you do multiple filter calls, it's like select.where.where.where. You get the stuff is joined by and. Some variety for returning results from query. If you have a query object and you say .all, you get a list back. If you have a query object and you say .first, it's going to limit it to one row and give you just the first row. You notice that first modified the statement for us. There's another thing that's kind of like first but not quite the same called one. One is not going to modify the statement. It's going to give us the first row without doing the limit. But what one does that first does not is it actually makes sure there's one in exactly one row. Otherwise, it throws an exception. So if you ask for a row that doesn't exist, you will get a no result found. And if you ask for a row that there's more than one row, you get a different exception called multiple results found. So one is often if you're building like your RESTful interface, which is like my web service /5 is the ID. You want to make sure that there's one row for 5. If there's no rows, that's a no result found. You throw a 404. If there's multiple results found, your app broke. So it's a handy way to distinguish between those two different kinds of conditions. Yep.
If I'm stupid and I query the whole table, that's a big table. The whole table's going to come over the wire, and then.
It will, yeah. It's the whole thing. Well, that's because you're using one, yeah. But that's why multiple results found is an error condition. It shouldn't. Like in theory, you're building your app. If you have a query that's doing multiple results, you would know long before it's a big table. But yeah.
I got a kind of question. You showed us earlier there's like a keyword as well. Can in support multiple columns?
Yeah, we have that. That's a more recent. I'm not sure that every database can do it, but Postgres does it. There's a tuple constructor that will give you a Postgres style tuple. So you say tuple xy dot in, and then you give it tuples. Yeah, I don't know that every day. I know if Postgres does it. I'm not sure if MySQL it does. Okay, then it works there too. If the syntax works, yeah, yeah. So that was the basic talk. And then there's another section which is the ORM Advanced, which is where we get into where people spend 99% of their time banging their heads against the wall with the ORM, which is the joins and the relationships. Like everything we've done so far is all the easy stuff, and then the next set of slides is basically where all the angry tweets are. So we're now going to go to angry tweet slides. Yeah.
For the one, would you recommend in Python doing a try except on both not found and multiple return? Or
I will do the try except on the not found and throw 404, and then let the multiple propagate outwards to whatever is catching it on the outside. Because one is an application failure, one is a one is a business case failure.
So what about a pattern where you check and see if the count is 1 and then you query knowing that the
Well, you could do that. I mean, typically we try to not emit more statements than we need to, because doing a count means another select statement.
Right.
So you could. I mean, if you have that might be what you're doing. If you have something where you're counting things ahead of time and you happen to know that, you could use that. Although one thing about the select like that is that it is, if your transaction didn't have a high level of isolation, theoretically another row could have been added between the time that you did your count and, well, it depends what you're doing. If you're doing some really hot, like transaction processing thing with tons of rows coming in, that you might not. Yeah. So yeah. Anything else? Yeah.
Is there a strategy for handling returns? Kind of building off that question earlier about querying all you might get like 20 million rows. You don't want all that loaded in memory for example. Is there a way to like paginate?
Yeah, there's a lot. So this is the problem. In the old days, I think in the 90s, when I used to work with database APIs, they used to generally stream the rows over the wire to you, and you would get as you select the rows and you fetch them, The older DB APIs would do this. They would just, older database adapters like for Perl and Java would not buffer all the rows in memory first and then hand them to you. They would be like over the socket, getting the row, getting you the row, getting another row, giving it to you. And then somehow when I got to Python, I started using these database APIs. The vast majority of them don't do that. They will, like if you use CyclePG2, which is a great DB API, and you load a table with 1 million rows, it will load the entire table into memory before it gives you the first row. And that's CyclePG2. That's not anything with SQLAlchemy. That's CyclePG2. Now, if you don't want to do that, you can use a feature called server-side cursors, which they offer. But other DB APIs don't even have that feature. So, like most of the MySQL APIs will buffer everything. So the first problem is that if you want to select an enormous table, 90% of the time, before SQLAlchemy even gets anything, the whole thing's been loaded into memory anyway. So typically with pagination, you want to get chunks of a table per statement. And there's a lot of ways to do that. The limit offset we're doing is kind of the most simple approach. Limit offset has the disadvantage that if you have an offset of like 1 million, most systems will actually scroll through all the 1 million rows before it gives you the next page. So as you keep paging down, it gets slower and slower and slower. So this is, again, one of these things where there's a lot of easy ways to do it that don't scale. The way to make it scale is you have to write a pagination that's very specific to what you're doing. Like if you're paginating along dates, the best way is to look at the date of the current page and then query for where data is greater than that date and make sure the data is indexed. So yeah, there's a lot. And if you use Flask, there's tons of pagination tools. I find them all to be a little scary because they're all just doing things for you and they might not work that great and they end up not being efficient. Pagination is hard. It's like get or create. It should be easy, but it's the easiest things are hard to do efficiently. But yeah, so there's a lot of libraries that do pagination. I tend to write my own thing. I will also use something called a window function, which is a little more elaborate. There's some examples on the wiki on SQLAlchemy Bitbucket page. So yeah, the answer is yes, and it's a big topic. Yep. Which leads us to the last set of code, which is the ORM Advanced, which is all the joins, all the relationship between tables. And this is really this is where everyone's working all day. This is where I'm fixing all the bugs all day. This is where everyone's angry tweeting all day and confused all day, and also, pretty impressed at how much it does do correctly all day. So it's a good thing. So we'll start again with the same old user we've always seen. Nothing new here. And then we'll make the address table like we did before. So this looks like we did in core. We have foreign key in the declarative style. And then we have something new from SQLAlchemy .orm import relationship. So here's the first thing that annoys people who use like Django or whatever. It's like, okay, this address class has a relationship to the user class. Why do I have to do user ID and user twice? Why? That's so annoying that I have to do both things. And I agree it is a little annoying. There are some patterns to make this more automatic. And I actually talked about some at my PyCon talk this year, and there are recipes, and you can use them, and there's some ways to make it easier. But for the moment, this is the API that we've had for years, and people know it. There's ways to make it quicker, but really, if you just do the foreign key, it's not that big a deal. The idea here is that there's a foreign key in the database between the address table and the user table, so you make this column. But then the ORM needs a special different instruction to say also, hey, I also want there to be an ORM Python level magically handling relationship between user and address. And when you make this relationship, there are many, many configuration features for this thing. But in a simple case like this, SQLAlchemy will at least figure out, hey, the only way I can go from a user object to an address is through this foreign key. So it knows to use that. If it doesn't know to use that, because maybe there's a lot of foreign keys here, or maybe there's no foreign keys, it'll throw an error. It'll be like, hey, I couldn't find any foreign, and if you've seen, this is the first error I couldn't find any foreign keys between address and user. You made a relationship, but I don't see a way to join them, so please tell me how to do it. or it's ambiguous. There's many ways I could join between the two tables, and I don't know which one to use. Can you please tell me? So I don't know if there's a name for this in computer programming, but it's kind of like documentation through exception messages. Like, I didn't want to write documentation being like, okay, so if you have a class and you have more than one foreign key, you need to do this. If you have 0 foreign keys, you need to do this. I just said, just do this, and the exception messages will tell you what to do if it doesn't work. And I think that actually, I don't know if there's a name for that, but it actually goes pretty far. The exception messages, who's worked with relationship before and got the big crazy paragraphs, they're kind of like documentation for what to do next. It's kind of like a wizard almost. It's kind of like an inverse wizard. Like instead of doing the work, it's just kind of like, no, do this. And there's a ton of code in relationship to format those messages because it was easier for me to make it throw a very elaborate exception that really tries to tell you exactly what you did wrong, rather than trying to document up front how to do it. Because it would be like, first do this, and people would be so confused. Instead, just do that, and as soon as that doesn't work, it'll tell you what to do. So, and there's no name for that, but you know that it's kind of a documentation to exception. Yeah. So okay. So that's another namespacing issue. Is that when you use SQLAlchemy, if you say from SQLAlchemy something, import something, that means you're using the core. And as soon as you want to use the ORM, which is this very separate thing from the core, it's .orm. And so that's kind of the idea, is that nothing, if you look at the source code of SQLAlchemy, I think there might be the tiniest exception to this. Nothing in SQLAlchemy knows about .orm. It's only, the dependency is only in one direction. I think that actually might be completely true. I don't think there is even one little part. There might be. If you look, there might be. But pretty much, SQLAlchemy ORM depends on SQLAlchemy, but not the other way around. And yeah, I make it explicit as to which, because I really wanted people to know you're not using ORM, using the core. If you're not using an ORM, it's the core. If you didn't type .orm, you're not using the ORM. It's that simple. It's totally non-ambiguous. All right, so like we always do, this should be old hat. We create some tables, make an engine. Create the tables, you get the user table, the address table, foreign key, same thing we've seen over and over again. See how we keep building on the same thing? Make it more elaborate each time. Okay, insert some data. We add all into the session table. And now we've got the diversity going, so it's good. Add all, user, Wendy, Mary, Fred. And then what do we do? It ran the code. It inserted those rows. When we make those objects, if we make a new object, because we made that relationship called addresses, any instance of a user object now has this implicit list sitting on it called .addresses. So if you hit .addresses, suddenly there's this list that's empty, nothing in it. We can put stuff into it. We can make these new objects called address objects and put them in the list. And what happens is the list is populated with the addresses, but then also, because of the way we define our relationship, this thing called a backref points the address objects back to the user. And I'll go back in case I just did that too quickly because I didn't really point it out over here. Okay. There is address, and address.user relates to a user, and there's a backref addresses. So that's a bidirectional relationship. Addresses is the one-to-many, and user is the many-to-one. Because anytime you have two tables with a foreign key, one-to-many and many-to-one are implied by both. You don't have to make both of them explicit in SQLAlchemy. You can just deal with one side or the other. But we give you this convenience feature. If you want to make both of them at once and have them point to each other, you can do that with a backref. Does that make sense? Sort of? See, this is really much more elaborate stuff than the core, but this is the stuff everyone knows because this is what's in day-to-day SQLAlchemy usage. So with a backref, the backref does is as you work with the objects in Python, it makes those connections for you in memory. The Jack has a .addresses collection, and then each element in that collection points back to the Jack user. Same object. Nothing has been pushed to the database yet in this case. Now, when we add that Jack user to the session, it actually cascades all of the addresses as well. It's automatically going to put everything associated with Jack at the ORM level into the session. So we have not just the Jack user, we have the three address objects are also in the new collection, pending, ready to be inserted when we do the commit. So we have all those things. The unit of work, a lot of what it's concerned with is knowing what order to put stuff into tables. It knows that as each address row has a user ID that is a foreign key constraint to a primary key, it knows that it must first insert the row for the user table. There's no ID explicit in our insert statement, so it uses SQLite's auto increment to get at the new primary key at number 5. Unit of work then takes that number 5 and figures, hey, number 5 is going to go into the user ID of each of these address rows. It does that synchronization. That's some of the work that the unit of work does. And then when it does the insert for the 3 address rows, it has number 5. This came out of nowhere and is in the process there. And that's a lot of the mechanics that the ORM automates for you. You could do that by your hand, but it's a pain in the butt. You can have the ORM just automate it. It's good to know what it's doing, but that's a lot of work we didn't have to do. I mean, at this point, the ORM is saving us a lot of trouble. If we did this all by hand, it would be a lot more code, a lot more boilerplate, a lot more chance to make mistakes and do things inconsistently. So we've committed, and we, again, do the expiration. Everything in Jack is empty. You press return to look at the Jack.addresses collection, and SQLAlchemy is like, oh, he wants to see the addresses. Well, first let's refresh the Jack row to see that the Jack row is not deleted. There it is, and then let's go get the addresses collection so we can see that, and we get it all back. If we were not echoing the SQL, you would just see the result come back. And that's more lazy load. That's actually 2 lazy loads. And then SQLAlchemy collections, this is unlike most ORMs, are persistent collections in memory. It's actually a regular Python list, and it stays there without refreshing itself. It's just a list in memory. A lot of ORMs, if you keep hitting the same collection, it'll load it every time because it's easier to do that. It's easier to code. SQLAlchemy has a lot more crap going on in the background so that the addresses collector is cached like that, and you can see it again. What is this slide about? I have no idea. Collections and references are updated. Oh, right. Yeah. So I do it all the time. All right. So a lot of people will have an issue where they're dealing with their objects. They load their objects, and then they're like, okay, well, user ID equals 5, and so I set address.userid equals 5, and I expected user.addresses to have my address in the collection, and then it didn't happen. Because SQLAlchemy doesn't work in that direction, meaning you can hand manipulate these primary keys and foreign keys. You can make them set to whatever you want, and if you commit all those changes to the database and then you load the objects into memory, everything will load the way you expect. But if you move all those primary foreign keys and assign them to different numbers and don't actually refresh anything, it's not going to actually move the objects together for you. It wants you to work in the other direction. It would prefer that you forget about primary keys and foreign keys when you work the objects and just work with the collections and the references. And if you want to point an address to a certain user, just do it directly, like address.user equals my new user. This is where we kind of say, don't be concerned about foreign keys and primary keys. Work with the references directly. And then when you flush the session, the SQLAlchemy session will handle the fact that the foreign key of the address table changes from 2 to 4, and that whatever 5 to 4, and all that stuff happens. So, yeah.
This is a dumb question, but it's my question. In prior slides, you had name equals ed, and in this you've got a filter by name equals red.
Yeah. So filter by. Yeah. So there's 2 functions on the query. There's a filter function. There's a filter by function, and they're different. The filter function is the one that does the equals equals. The filter by is a little shortcut thing, and that just gives you this quickie keyword thing, which is really it's just shorthand. This filter by name equals Fred is shorthand for filter user.name equals Fred. The reason now in earlier versions of SQLAlchemy there actually was a method I think called I forgot what it was called that actually had both styles at the same time, because in Python you have positional arguments and then keyword arguments. And I actually separated them because people were so confused by that I made them separate method names, filter by, as opposed to filter.
Why couldn't you make the other one filter name equals ed?
Well, so when you work with this filter by, it's actually calling filter for you. It's actually going to say name is actually the name column on the user class. It's going to actually do more work to automate what we're doing. The filter with the double equals is more explicit because we actually tell it it's the user.name. We actually say what the parent table is. One of the things that's happening here is the fact that we say name. So what if we said session query user comma address? We had both entities at once, and they both have a column called name. What would filter by name mean? It would probably actually I think it would pick the first one, but filter by. But we don't. It's not as good because we can't choose address.name because filter by doesn't know to do that. Filter by is just kind of a shortcut. And maybe I shouldn't do it that much in these slides because it is the fact that it is changing. The style might be confusing. Filter by also, if we use filter directly, we can also use other kinds of operators besides the equals operator. We can use not equals. We can use greater or less than. When we use filter, we're dealing with the Python operator overloading thing that SQLAlchemy does. When we use filter by, we're not. We're skipping that whole thing. So we have a lot less facility with filter by. But it works for the very quick and dirty, extremely common use case of column equals value from one entity. That's kind of the, yeah.
So we're using Django.
Yep.
And a few years ago, somebody had to figure this out. We have a few operations that create thousands of entities that all have relations to other entities. And we save them all in a single transaction, but the process of through the loops is getting the relation entities and doing things on them. We were running into issues where certain entities didn't know about their dependent relationships because they hadn't been saved yet. In this example, I saw that you saved, and then you mentioned the foreign key. Don't take in foreign keys or primary keys because the objects know about each other. Is that true before actually saving the?
Yeah, it works out really smooth because first of all, you're linking things together the way you want. The moment anything that you do impacts SQL, it's going to flush, and then you'll get it back. So it tends to be very, very consistent within the transaction. So yeah, the Django is not going to be as good with that kind of stuff. That's more about the identity map because Django doesn't have the identity map. So if you made those connections on one object, you load the object later, it's a different object. That's why the identity map is handy because if Jack addresses and user is already loaded up, you load Jack later on, it's the same object, has the same state already there. So you save having to do more round trips again. So the identity map is pretty critical. My voice is just going to make it to the end. I'm really losing my voice now. Not a speaker. Okay. So on that topic of querying from two classes, this is querying from two tables at once, the user and address. And then we can filter, and we can join them together. And it'll do what's called an implicit join, which means it's going to give us the user and the address at once, and it'll equate the two tables together. There's no join keyword, it's implicit. If you want to make an explicit join, you can say, give me user, comma, address, and then join to the address, and then give me the on clause. So this is a SQL join, right? Join from two tables. The on clause relates the two sets of rows together. The most succinct way to join is just to say, hey, join on the user addresses collection on that relationship. That relationship can tell you can tell SQLAlchemy what it needs to know in order to join. And this is what I meant earlier on by querying the database in terms of the object model. The fact that we have user address and user.addresses, it knows that means a join. It makes us say the word join explicitly, but once we do say, hey, I want you to join, we can tell it how to do it more succinctly than doing a more explicit expression. If you want to do this, you can do this too. It will, in many cases, just figure out the best way to join the two. If there's more than one foreign key, again, it'll say it's ambiguous. If there's no foreign keys, it'll be like, I don't know how to join these two things, but in our case, it's clear. So it, again, does the same query. It knows how to join the two things together. This is a pretty common way to do it. And you can see the rows that we're getting back are actually tuples of user comma address. And because we're joining, if a single user has 3 addresses, we get back the same user 3 times in the tuple because that's the Cartesian product, right? User with his first address, user with his second address, user with his third address. That's what we get back. Also, there's actually a lot more user rows in this table than just this one, but we're only getting this one back because we're doing an inner join. So that is, we're only getting a user object back that actually has address rows present. The user objects that do not have address rows present are not being loaded from this because we're doing an inner join. Inner join, outer join, familiar? Those of you who've stayed this long, this is totally normal. Not at PyCon because they paid for it, but at the PyGothams, this is what it does.
So if you want to do an outer join.
Yeah, you say outer join, outer join. I might have it coming up. Maybe not. Session query, I would say here, say session query. Outer join. Well, that's just the name, so yeah, I can do this right. So you get an outer join, and so for those rows that don't have any addresses, you get none or null back, and you get the jack that many. I forgot what I did here, but you get the 2 back for that. Should be 2 or 3. I'm losing track. All right. We can, if you want to join from if you want to select, if you want to select from the address table first, address join user, you can say, hey, select from address, join to address user. You can do that instead. Sometimes that's important, depending on how you're building up your query. If you don't say select from, it'll go by how you did session.query user first, then address. It'll be like user, comma, address. If you do select from, you can flip it around if you want. More join stuff. When you want to refer to the same table more than once in a SQL statement, we have to give it a new name called an alias. So say we want to join from user to the address table in 2 different contexts. You have to give it a name. SQLAlchemy gives you this thing called aliased. This is also in core, but this is the ORM version. You don't have to come up with a name yourself. You refer to the alias just based on using that object as the parent of the columns. This is where we get to that namespace thing again. So instead of saying address.email address, we've made these 2 alias objects which look like an address class, but they're not. They're an alias of it. It means they represent a different set of rows, a different set of columns in the statement. Same row, different set of columns within the rows that we get back. Correct. So we have the query for the user class, and we can join to the first alias address row, and then we can join to the second alias address table. Sorry. And for each one, we can put different criteria, and we can get back all of the users that have both an address with Jack at Gmail and an address with Jack at Hotmail. And that will give you this. And then here's where SQLAlchemy is doing some more stuff. Where's my anon? Yeah, it's no. All right, so what it did was it said select from user, join to address as address _1 on user address _1, join to address as address _2. Now, we didn't have to worry about this address _1 _2 business. When we're in Python, we refer to different tables and things that we select from by the Python identity of the object. So that means every time, it's kind of a conceptual thing. Every time we refer to A1 in our Python code, it's going to be address _1 in our SQL code. Or it could be address _12. It depends on how the thing works out. But it will be the same every time for a given statement. If we refer to A2, we don't care that the name is address _2. The actual string name doesn't matter. It's just generated on the fly. We deal with just the fact that A2.email address refers to that particular alias. So this is a little bit of indirection in how the metadata constructs and ORM constructs we use translate into a string. This is also totally a core thing as well. Core has alias as well. This is the ORM version of it. So this is where the SQL expression language and its implementation within the ORM gets a little more crazy. Makes sense, sorta? and we can join with subqueries. I'm only 10 minutes left, so you can do this kind of thing. This is more. The ORM tutorial has this. You want to do a fancy query with a subquery. You can join to a subquery. Exercises, no new. Here's some eager loading. This is important. So this is the other, every anti-ORM article you ever read will be like, oh, the n+1 problem, the n+1 problem. Who knows what the n+1 problem is? All right, so the n+1 problem means I want to load a bunch of rows from the user table, and for each one of the users, I also want to load all their addresses. n+1 means that that's going to be a select statement for all the users, and then for every row, all of n, it's going to do select start from addresses where user ID equals 1, select start from address where user ID equals 2. And that's called the n+1 problem, and this is an example of n+1, which is that. So what happens is we loaded all the users, and then for each one, it said dot addresses. Oh, that's a lazy load, which is why you don't want to do lazy loads, because they are like a surprise. And that's the best, this is the big anti-ORM argument, is that this implicit loading means that someone can write very simple code, very innocuous looking code, like that. How simple is that? And then it runs like crap. And that is a problem. And the way we've solved it is, A, we expect you to look at what the SQL is doing when you are getting your app to work, and then you have to go and optimize those things with eager loads. It's true that that is not a completely perfectly magic solution. It requires that you know what the n+1 problem is. It requires that you look at the queries, and it's, yeah, for like someone that uses like a MongoDB thing, it's totally anathema to have to do this. But that's relational databases. SQLAlchemy makes it really, really easy to see the SQL, and when you build your application, you want to be going through it and seeing what it's doing to make sure you're not omitting too much stuff. Now, it's not too hard to become pretty savvy pretty quick, that you're going to know that user.addresses does a lazy load. I mean, I don't have to think about it at all. You know when you need to optimize something. So what we do in SQLAlchemy is we can't make this completely magically gone. The problem is there. We make it as easy as possible to solve. We make it so frickin' easy to solve, but yeah, you have to solve it still. Sorry. And everyone seems to be okay with it. So the problem is there. You diagnose it by seeing it. Look at all these freaking queries for this one operation. It's not good. It's true. And if you don't know SQL, then yes, you will fail. Let's fix it. Let's say, hey, query user, we happen to know that we're going to want ahead of time to get these addresses as well. So let's send a special directive to the query, hey, also get me the addresses pretty quickly too. For every user you get, please do a query that will very efficiently get all the addresses in one big shot too, so that we don't have 10, you raising your hand or?
Yeah.
Yeah. Okay. So do this subquery load thing, which is going to just basically emit different SQL. So the problem though with ORMs and n+1 is that you need to know ahead of time what you're going to need when you get your objects back. If you don't use an ORM, you have the same damn problem. So it's not like it's any worse. It's just that the criticism is that using an ORM, you are lulled into thinking you don't have to worry about it. So I say, you still have to worry about it. Problem solved. So when we run this, you get just two queries. In this particular case, you get the user query, and then it does this thing where it takes our query and embeds it in another query to get the addresses back. You get two queries. This is a fairly okay query. There's better way. There's other ways to do it too, and you get back everything pretty quickly without too many round trips. Yeah.
You said that you would notice this by looking at the SQL.
Yeah.
Is there a really easy way to just log all your SQL?
Yeah.
And be
So usually when you do create engine, you put echo equals true on it, and that'll give you everything. The way this slide thing is doing is it's doing Python logging. You say Python get logger SQLAlchemy engine set level logging.info, and set up your logging config, and it's done. If you just say echo equals true, same thing. Echo equals true is we'll dump it the standard out.
Okay.
Without any guess. So I made it really super. That was the thing. Every ORM I ever used made it so hard to see the SQL. They made it so hard. Yeah, and they made it really hard because you shouldn't have to worry, and they were wrong. You need to see the SQL. You must watch what it's doing. You have to be. That's why everything, all my example, all these things, it's constantly spitting out SQL. Anyway, join load is another kind of eager loading where it'll just do a join in one shot. It'll just do. It's the same. It looks the same. Instead of saying subquery load, we say join load. We do all the same code. We get a very different output in the SQL, very different performance profile. We get the users with a left outer join, which might not be as efficient as the inner join, get the same result back. We can just change the loading strategy without changing what the query returns as far as data. That's a big deal, SQLAlchemy, is that you can make all different kinds of queries that return the same exact data by modifying these options. I want join load here, subquery load there, lazy load there, I want some other load there. But we go through this huge hoops to make sure that the data you get back is the same. It never changes. And when it does this joining stuff, if you have like a limit on the query, it'll go through a lot of trouble to wrap things in subqueries and put things on the outside of it and make sure that the actual result doesn't change. And that's what the next slide says, as usual. I'm always anticipating my slide. Equal does not change the result of the query, only how related collections are loaded. Do you see that? And yeah, so this example is a little crazy. This is where I'm querying the address table, I'm doing a join to the user table, and then I'm filtering on those rows that are for username Jack. And then totally separately, I'm also doing a joined load. So that's crazy. It's crazy talk. So we have select from address and user, address join a user. That's the join I did up there. But then join load gets in there with its left outer joins. It's actually two separate joins. And you see it does all kinds of anonymous aliasing on the collection. And it gets the collection back with its own. So basically, when you use eager loading, especially join load, SQLAlchemy takes your query and says, okay, your query is your query. But I'm going to do all my own stuff over here with all my own names, all my own special symbols that you're not going to know. But your collections will magically be there when you get the results back. So it's like your query is here, and my query is over there, and we're going to put them together. And you worry about your part, I worry about my part. If you really want to see your part without my stuff, turn the eager loading off so you can see your query. And then turn the eager loading back on, the query gets crazy again, gets all big. And then when you get your rows back, my collection will be there too. So you kind of cooperate with join loading to get that result. It's cool, right? Those of you that have remained, so they were the ones who think that's cool. If you want to join and join load at the same time, but not emit two joins, which is a very common case with a many to one, you can say, hey, I'm going to query for address, join to address user, and then as you load those rows, can you also please take that user and stick it on each address object? And that will do that. So you get just the one join, but in the results, you get back the .user is also there for you. So contains eager. If that didn't make any sense, if you use SQLAlchemy for a while and you broke a join load, you'll eventually be like, oh, I wish I could not have to write this join twice. I want to write this once and use it. You'll know what I mean. You'll use contains eager. And then there's the big final exam, which you can all go home and do. And send me an email with your final exam result. This is the bank account example. And that is it. And my voice is gone. All righty.